Welcome to the Ultimate Salesforce LWC Coding Challenge Series, 15 handcrafted, real-world challenges designed to take you from writing your very first Lightning Web component to building a complete mini-application. This isn't just theory. Each challenge mirrors the exact kind of tasks you'll face in job interviews and real project work. You will master core skills like dynamic search, record display, and data tables. Reusable modals, event handling, and form patterns. Bulk operations, inline editing, and error handling. Advanced state management with Lightning Message Service. The Capstone Challenge. It all builds up to the capstone, where you'll design and code a full Account Explorer mini-app, proving you can think at the application level, not just the component level. Whether you're preparing for interviews, sharpening your Salesforce developer skills, or aiming to step up as a system designer, this series is your step-by-step guide. So buckle up, 15 challenges, one epic journey. Let's dive in. LWC Coding Challenge 1, the Dynamic Search Component, Fresher Level. Question: what is this challenge and why does it matter? Answer: this is the quintessential LWC interview task. It tests the three core pillars of a modern developer: performance, security, and component architecture. A naive implementation would fire an Apex call on every keystroke, overwhelming the server. The key is to implement debouncing to be efficient. Acing this proves you build professional, production-ready components that enforce sharing rules, object permissions, CRUD, and field-level security, FLS, a non-negotiable skill for any LWC developer role. The challenge and interview timebox. The task: an interviewer asks you to build a component that allows a user to search for account records by name. As the user types, a list of matching accounts should appear. The search must be efficient and secure. Realistic time allocation: core coding task, live 15 to 20 minutes. Full interview discussion, with follow-ups can extend to 30 to 45 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, great, a classic search component. To confirm, an input will call Apex to find accounts. The key requirements are performance, so no Apex calls on every keystroke, and security. We will also handle loading states and notify a parent on selection. Sounds good. 2. State your plan. I will start with the backend Apex method to define the data contract, ensuring it is secure. Then I will build the component's UI with HTML. Finally, I will implement the core logic, including debouncing, in the JavaScript file. 3. Code and narrate. As you code, explain your decisions. I'm adding with security_enforced to the SOQL. This is a best practice to ensure the user can only see data they have access to. Or, now I'm implementing debouncing with set timeout to prevent spamming the server. The component bundle, files we will create. Dynamic account search.html, the user interface, the template and structure. Dynamic account search.js, the core logic, the component's brain, handling events and data. Dynamic account search.js meta.xml, the configuration, tells Salesforce where the component can be used. Account search controller.cls, the server-side logic, the Apex class that queries the database. Dynamic account search.css, the styling, for a custom look and feel. Here is the user interface HTML file, the LWC HTML, dynamic account search.html. Disclaimer: always test code in a non-production environment. The UI starts with a standard Lightning input. The key is the onKeyUp event listener, which calls our handleKeyUp JavaScript function every time the user types, triggering our search logic. This demonstrates conditional rendering. The Lightning spinner provides crucial user feedback, and it is only displayed when our JavaScript property isLoading is true. We iterate over the accounts array using for each. The key equals account.id directive is mandatory for performance. We store the record's ID in a data ID attribute and wire up an onClick handler for selection. Here is the core logic JavaScript file, the LWC JavaScript, dynamic account search.js. Disclaimer: always test code in a non-production environment. We start with all necessary imports. This includes the base LWC class, our Apex method, and the standard showToast event for showing notifications. A constant is defined for our debounce delay. Using a constant makes the code cleaner and easier to modify. We define our components' reactive properties. These will hold the search term, the results, the loading status, and a reference to our debounce timer. This is a computed property, or getter. It derives its value from other properties, keeping our HTML template's logic clean and readable. This function is our event handler, called every time a key is pressed in the input field. This is the first half of our debouncing logic. We clear any previously scheduled search. This ensures we do not fire off multiple, unnecessary Apex calls. We get the current value from the input field. This is the second half of debouncing. We schedule our search logic to run after a 300 milliseconds delay, only proceeding if the user has stopped typing. This function makes the imperative call to our Apex method using modern async or await syntax for clean, readable code. The try or catch block provides robust error handling. We attempt to call Apex and assign the results. If the Apex call fails, we clear the results and dispatch a toast event to inform the user of the error, which is a mature UX pattern. The finally block is crucial. It guarantees that our loading spinner is turned off, regardless of whether the Apex call succeeded or failed. This handler is called when a user clicks on one of the result items in the list. We retrieve the account ID that we stored in the data ID attribute in our HTML. We then create a standard custom event, preparing to notify parent components of the selection. Finally, we dispatch the event. This is the primary LWC pattern for child-to-parent component communication. Here is the configuration XML file, the LWC configuration, dynamic account search.js meta.xml. Disclaimer: always test code in a non-production environment. The API version tag locks the component's behavior to a specific Salesforce release, ensuring stability. This tag is required to make our component visible and available for use in tools like the Lightning App Builder. The target set configuration specifies exactly where this component can be placed by an administrator. Here, we have enabled it for app, record, and home pages. Here is the server-side logic Apex file, the Apex controller, account search controller.cls. Disclaimer: always test code in a non-production environment. The class is declared with sharing. This is a critical security practice that ensures the query respects the running user's sharing rules. The method is exposed to LWC with at or enabled. We set cacheable equals false because it is called imperatively and the results change with every input. Caching is not appropriate. This is a modern best practice that automatically enforces field-level and object-level security for the user. Mentioning this in an interview is a huge plus. Here is the styling CSS file, the styling, dynamic account search.css. Disclaimer: always test code in a non-production environment. We apply styling to our result items. The cursor, pointer rule changes the mouse cursor to a hand, providing a clear visual cue that the item is clickable. We add a hover pseudoclass to provide feedback when the user mouses over a result. The background color change makes the UI feel more responsive and interactive. Common pitfalls and how to debug them. Pitfall 1: no results appear. Check the browser's developer console. You might see an error from the Apex call. Also, ensure your Apex class has been deployed successfully and the method name matches exactly. Pitfall 2: spinner never stops. This usually means you forgot to set this .isLoading equals false in a catch or finally block in your JavaScript. An error might be occurring, but the UI is stuck in a loading state. Pitfall 3: firing too many Apex calls. If you forget the debouncing logic, open the Network tab in your browser's developer tools. You will see a new search accounts call firing for every single letter you type. Follow-up questions, from junior to senior. Follow-up question 1, you are calling Apex imperatively. What's the trade-off versus using the @wire service? Answer, the @wire service is for reactive data fetching. It runs when the component loads or when a reactive parameter, like at API record ID, changes. This search needs to be triggered by a user action, typing, so calling the Apex method imperatively, on demand, is the correct pattern. Using @wire here would not work as intended. Follow-up question 2, how would you improve performance further for very common search terms? Answer, beyond the server-side debouncing, a senior-level optimization would be to add client-side caching. I would create a simple JavaScript map in my component to store the results of recent searches. Before making an Apex call, I would first check if the search term exists in my map. If it does, I can serve the results from the client-side cache instantly, avoiding a round trip to the server entirely. Follow-up question 3, curveball, how would you make this component accessible for users who rely on keyboard navigation? Answer, this is a great question that shows a focus on user experience. I would enhance the component to handle arrow keys, arrow up, arrow down, to navigate the results list, and the enter key to select the highlighted item. This involves adding a keydown event listener to the input, managing an active index property in the JavaScript, and applying a dynamic CSS class, for example, isActive, to visually highlight the selected result. What the interviewer is really looking for. Performance mindset, did you immediately implement debouncing without being asked? This is a key differentiator. Security by default, did you use with sharing and with security_enforced? This shows a professional, security-first mindset. Mature UX, did you provide good user feedback, loading spinner, no results message, and handle errors gracefully with a toast notification? Component architecture, do you understand when to use imperative versus wired Apex calls and how to communicate between components using events? Your turn, the practice challenge. Take this component to the next level. 1. Reusability. Add at API properties for object API name and search field API name and modify the Apex to use dynamic SOQL, making the component reusable for any object. 2. Scalability. Implement pagination in your Apex method to handle cases where more than 10 results are found, and add a Load More button to the LWC. LWC Coding Challenge 2, the related record data table, fresher level. Question. What is this challenge and why does it matter? Answer, this is another foundational LWC interview task, and it is the perfect counterpart to the dynamic search. Where the search component tests imperative Apex calls, this challenge tests the @wire service, which is the primary way LWC gets data reactively. Displaying a list of related records is arguably the most common use case for a component on a record page. Acing this demonstrates your mastery of the LWC data binding model, component context, and the ability to use core components like Lightning Datatable effectively. The challenge and interview timebox. The task, the interviewer asks you to build a component that can be placed on an account record page. It must display all of the account's related contacts in a Lightning Datatable. The table should show the contact's name, email, and phone. Realistic time allocation, core coding task, live 10 to 15 minutes. Full interview discussion, with follow-ups can extend to 25 to 30 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, a related list component. This is a great use case for the @wire service to fetch data reactively. To confirm, the component will get the account's record ID from the page, call an Apex method to query its child contacts, and then display them in a standard data table. Sounds straightforward. 2. State your plan. I will start with the Apex method, making sure it is cacheable so it can be used by the @wire service. Then, in the JavaScript, I will define the data table columns and wire up the Apex method. Finally, I will build the HTML template to render the Lightning Datatable and handle the loading and error states provided by the wire service. 3. code and narrate. As you code, explain your decisions. I'm using the @API decorator on record ID so the component can receive the ID from the Lightning record page. Or, I'm making the Apex method cacheable equals true, which is a requirement for the wire service. Or, the data for the data table will come from the contacts.data property provided by the wire service. The component bundle, files we will create. 1. Related contacts.html, the user interface, will contain the data table. 2. Related contacts.js, the core logic, will use @wire to get data. 3. Related contacts.js meta.xml, the configuration, to make it available on record pages. 4. Contact controller.cls, the server-side logic, the Apex class to query contacts. Here is the user interface HTML file, the LWC HTML, related contacts.html. Disclaimer: always test code in a non-production environment. We start with a conditional template. The content inside will only render after the @wire service has successfully returned data and populated the contacts.data property. This is the core BASE component. We bind its data attribute to our wire data and its columns attribute to a definition in our JavaScript. Key field is required for rendering performance. The @wire service also provides a convenient error property. We use another conditional template to display an error message if the Apex call fails for any reason. Here is the core logic JavaScript file, the LWC JavaScript, related contacts.js. Disclaimer: always test code in a non-production environment. We import the necessary decorators from the LWC module. @API makes a property public, and @wire is used to call an Apex method. We import our Apex method, giving it a local name getContacts that we can reference in our component. We define the structure of our data table columns as a constant array of objects. This tells the data table which fields to display and what their labels and types should be. The @API decorator exposes the record ID property. When this component is placed on a Lightning record page, the Salesforce framework automatically populates this property with the ID of the record being viewed. This is the @wire decorator. It calls our getContacts Apex method and passes the record ID as the account ID parameter. The $prefix makes the record ID reactive, meaning the wire service will automatically refetch the data if the ID ever changes. The function wiredContacts receives the result from the wire service. This result object contains either a data property on success or an error property on failure. We assign the entire object to our contacts property to use in the template. Here is the configuration XML file, the LWC configuration, related contacts.js meta.xml. Disclaimer: always test code in a non-production environment. This tag makes our component visible and available to be used in tools like the Lightning App Builder. The targets configuration specifies that this component is designed to be placed on a record page. This target config is a best practice. It restricts the component to only appear in the app builder for account record pages, preventing admins from placing it on unsupported pages like a contact or opportunity. Here is the server-side logic Apex file, the Apex controller, contactcontroller.cls. Disclaimer: always test code in a non-production environment. The class is declared with sharing to ensure it respects the running user's sharing settings for contact records. The method is exposed to LWC, and cacheable equals true is mandatory for any Apex method that will be called by the @wire service. This allows the Lightning data service to cache the results and improve performance. The SOQL query is simple and secure. It filters contacts by the provided account ID, enforces field, and object-level security with security_enforced, and orders the results for a clean presentation. Common pitfalls and how to debug them. Pitfall 1, the component shows nothing. The most common reason is for getting cacheable equals true on the Apex method. The @wire service will fail silently. Check the browser's developer console for an error message. Pitfall 2, the data table is empty but there's no error. You might have forgotten the dollar prefix on the reactive property in the wire call, account ID, record ID, instead of account ID, $record ID. Without the dollar, the wire service runs with a null ID before the property is populated. Pitfall 3, the data table shows, object. This means you bound the data attribute to the entire wire result object, data equals, contacts, instead of the data property within it, data equals, contacts.data. Follow-up questions, from junior to senior. Follow-up question 1, in the JavaScript, you wired the result to a function. What is the other way to use at wire and what are the pros and cons? Answer, the other way is to wire the result to a property, like at wire, get contacts, account ID, $record ID, contacts. The pro is that it is more concise, less code. The con is that you cannot run any logic immediately when the data returns. Wiring to a function, as we did, is necessary if you need to perform some data transformation or logic, like logging or error handling, as soon as the data arrives from the server. Follow-up question 2, a new contact is created for this account, but your data table does not update. How would you fix this? Answer, the wire service caches the data, so it will not know that the underlying records have changed. To fix this, I would need to give the wired property a variable, for example, wired contacts result. Then, from another function, perhaps one that handles a refresh button click, I could call the refresh apex parentheses function, passing it this .wired contacts result. This tells the LWC framework to clear the cache and refetch the data from the server. Follow-up question 3, curveball, the business wants to show a custom type field on the contact, which is a pick list. The data table currently shows the API name, for example, customer_direct. How can you display the user-friendly label, customer, direct? Answer, this is a great question. SOQL returns the API name for pick lists. The best practice is to handle this transformation in Apex by creating a wrapper class. I would create an inner class in my Apex controller with properties for ID, name, email, phone, and a new string property called typeLabel. The Apex method would query the contacts, loop through them, and populate a list of these wrapper objects, using contact.type.getLabel parentheses to get the display value. The LWC would then receive a perfectly formatted list, with no client-side transformation needed. What the interviewer is really looking for. Understanding of reactivity. Do you know that at wire is for reactive data and requires cacheable equals true? Component context. Do you know how to use at API record ID to make a component context aware? BASE component knowledge. Are you comfortable with the data and column structure required by Lightning Datatable? Secure Apex. Did you instinctively write a secure, bulk safe, and cacheable Apex method? Your turn, the practice challenge. Enhance this component by adding row-level actions to the data table. Add an actions column that includes a view action. When a user clicks view, use the Lightning or navigation module to navigate them to the standard record page for that specific contact. LWC Coding Challenge 3, the reusable modal or pop-up, intermediate level. Question: what is this challenge and why does it matter? Answer: building a reusable modal tests a developer's understanding of component architecture. It is a direct test of parent-to-child communication, controlling visibility with that API, and child-to-parent communication, notifying the parent with custom event. It also tests compositional patterns using slots. Acing this proves you can think architecturally and build a clean, maintainable component library, not just one-off solutions. The challenge and interview timebox. The task: an interviewer asks you to build a reusable modal component. A parent component should be able to open it, pass in custom content for the header, body, and footer, and be notified when to close it. Realistic time allocation, core coding task, live 15 to 20 minutes. Full interview discussion, with follow-ups can extend to 30 to 45 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify. Great, a reusable modal is a classic architectural pattern. I will build a generic modal component that a parent can control via an API property. I will use named slots for the header, body, and footer to make it super flexible, and the modal will fire a custom event to tell the parent when to close. 2. State your plan. I will start with the child modal's HTML and JS, defining its slots and events. After that, I will create a simple parent component to demonstrate how to use the modal, showing how the parent passes content into the slots and handles the close event. 3. Code and narrate. As you code, explain your design choices. I'm using named slots here instead of API properties for the content. This is a much more powerful pattern because the parent can pass in not just text, but entire components. The component bundle, files we will create. 1. Modal.html, modal.js, modal.js meta.xml, the reusable child modal component. 2. Modaldemo.html, modaldemo.js, modaldemo.js meta.xml, a parent component to demonstrate how to use the modal. Here is the user interface HTML file, the reusable modal, modal.html. Disclaimer: always test code in a non-production environment. The entire modal is wrapped in a conditional template. It will only render when the isOpen public property is true, which is controlled by the parent component. This is a named slot. It creates a specific placeholder where a parent component can inject custom header markup. This is far more flexible than a simple API text property. This is the default, unnamed, slot. Any content the parent places inside the CModal tags that is not assigned to a named slot will render here. This named slot allows the parent to pass in custom action buttons, like save or confirm, while we still provide a default close button for convenience. Here is the core logic JavaScript file, the reusable modal, modal.js. Disclaimer: always test code in a non-production environment. The @API decorator makes the isOpen property public. This is the key to parent-to-child communication. The parent component can now control this value to show or hide the modal. This is the child-to-parent communication. When the user clicks the close button, this method fires a simple custom event named close. It is a signal to the parent to take action. Here is the configuration XML file, the reusable modal, modal.js meta.xml. Disclaimer: always test code in a non-production environment. Crucially, isExposed is set to false. This modal is a utility component. It is not meant to be placed directly on a page by an admin. It should only be used programmatically by other components. Here is the user interface HTML file, the parent demo, modaldemo.html. Disclaimer: always test code in a non-production environment. We include our modal component, passing down the isModalOpen state property and listening for the close event with the onClose handler. This h2 tag has a slot attribute. This tells the LWC framework to render this markup inside the child's slot name equals header placeholder. Similarly, we inject a custom save button into the footer slot, demonstrating how to add custom actions to our reusable modal. Here is the core logic JavaScript file, the parent demo, modaldemo.js. Disclaimer: always test code in a non-production environment. The parent component owns the state. It maintains a single Boolean property to track whether the modal should be open. When the user clicks the Open Modal button, this handler simply sets the state property to true. This change is passed down to the child's API isOpen property, causing it to render. This handler is connected to the child's onClose event. When the child fires its close event, this method runs, setting the state property back to false, which hides the modal. Common pitfalls and how to debug them. Pitfall 1: modal does not open. The most common reason is a typo in the property binding. Make sure the child's API property name, isOpen, matches the parent's HTML attribute, isOpen, which is auto-converted from camel case. Pitfall 2: modal does not close. Check that the event name in the child, new custom event, close, exactly matches the parent's event listener, onClose. LWC automatically adds the on prefix. Pitfall 3, content does not appear. Ensure that the child component's HTML actually contains the slot tags and that the parent's content has the correct slot equals attribute if using named slots. Follow-up questions, from junior to senior. Follow-up question 1, in your design, the parent is responsible for closing the modal. Why is this a better architectural pattern than having the modal close itself? Answer, this pattern is called lifting state up and it creates a clear, unidirectional data flow. The parent owns the state, is modal open. The child is a dumb component that just signals its intent, I want to close. This makes the system easier to reason about. If the modal closed itself, the parent state would be out of sync, which could lead to bugs. Follow-up question 2, how would you make the modal close when the user presses the escape key? Answer, this requires adding a global event listener. In the parent component's rendered callback, I would add a window.addEventListener, key down, this.handle key down. The handle key down method would check if event.key is equal to equals escape and, if so, call this.close modal parentheses. Crucially, to prevent memory leaks, I would also implement the disconnected callback lifecycle hook to remove that same event listener when the parent component is removed from the DOM. Follow-up question 3, curveball, what if you needed to open a second modal from within the first modal? How would you manage the state? Answer, this is a great question about managing stacked modals. The parent component would need to manage the state for both modals, for example, is modal 1 open and is modal 2 open. The first modal, instead of just a close event, would need to fire a more specific event, like new custom event, open second modal. The parent would listen for this, set is modal 1 open equals false, and set is modal 2 open equals true. The key principle remains the same, the top-level parent should always be the single source of truth for the state of its children. What the interviewer is really looking for. Architectural thinking, do you understand how to build a component that is reusable and not hard-coded for one specific use case? Communication patterns, can you correctly implement both parent-to-child, at API, slots, and child-to-parent, custom event, communication? State management, do you understand the principle of lifting state up, where the parent owns and controls the state? Composition with slots, do you know that slots are the superior way to pass rich content and make components truly flexible? Your turn, the practice challenge. Enhance the modal to be more accessible. Implement the escape key functionality discussed in the follow-up question. Additionally, use JavaScript to ensure that when the modal opens, keyboard focus is moved to the first focusable element inside it, for example, the close button.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your Salesforce jobs interviews like Salesforce LWC Developer jobs, Salesforce Technical Architect jobs, Salesforce Solution Architect jobs, Salesforce Service Cloud Consultant or Specialist jobs, Salesforce Test Engineer jobs, Salesforce DevOps Engineer jobs, Salesforce Marketing Cloud Developer or Consultant or Specialist jobs, Salesforce Admin jobs, Salesforce Developer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based interview questions and answers, real-world problem-solving interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers. 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
LWC Coding Challenge 4, the Quick Create Form, Intermediate Level. Question: what is this challenge and why does it matter? Answer: this challenge tests a developer's judgment, which is a crucial intermediate skill. It is not just about writing code, it is about choosing the right tool for the job. The core task is to compare creating a record using the built-in Lightning Data Service, LDS, via Lightning Record Edit form versus a fully custom Apex-backed component. Acing this proves you understand the significant trade-offs in development speed, security, and flexibility. It shows you know when to leverage the platform's power and when you need to take full control. The challenge and interview time box. The task: an interviewer asks you to build a component that allows a user to quickly create a lead record. They want you to first build it using Lightning Record Edit form and then explain and implement an alternative version using a custom Apex controller, discussing the pros and cons of each approach. Realistic time allocation: core coding task, live 20 to 25 minutes. Full interview discussion, with follow-ups can extend to 40 to 45 minutes. How to ace the interview: your thought process. 1. Acknowledge and clarify: this is a great, practical challenge. It really gets to the heart of LWC architecture. My understanding is you want to see both the LDS approach with Lightning Record Edit form for simplicity and automatic security, and then a custom Apex approach for when more complex business logic is needed. I will build a single component that can toggle between these two modes to make the comparison clear. 2. State your plan. I will start with the LDS implementation using Lightning Record Edit form and Lightning Input field, as this is the best practice for simple create or edit scenarios. Then, I will add the UI and logic for the custom Apex path, writing a secure Apex method that includes manual CRUD or FLS checks. Finally, I will write a test class for that Apex method. 3. Code and narrate. As you code, explain the trade-offs. Notice with LDS, I do not need any Apex. The platform handles the DML operation and respects all FLS and validation rules automatically. Now, for the Apex version, you can see I have more control, but I also have more responsibility. I must perform these isCreatable parentheses checks in Apex to ensure the component is secure. The component bundle, files we will create. 1. LeadCreator.html, the UI with 2 conditionally rendered forms. 2. LeadCreator.js, the logic to toggle modes and handle both LDS and Apex submissions. 3. LeadCreator.jsmeta.xml, configuration to expose the component. 4. LeadCreatorController.cls, the Apex controller for the custom DML path. 5. LeadCreatorControllerTest.cls, the mandatory Apex test class to ensure code coverage and correctness. Here is the user interface HTML file, LeadCreator.html. Disclaimer: always test code in a non-production environment. We use conditional rendering to show one form at a time based on the user's selection, controlled by Boolean properties in our JavaScript. This is the LDS approach. We just declare the object and fields. The component handles layout, FLS, and saving. We only need to listen for the onSuccess event. This is the custom Apex approach. We use basic input components and must manage their state manually with onChange handlers. In the LDS form, a button with type equals submit automatically triggers the form's save mechanism. In the Apex form, we use onClick to call our custom save function. Here is the core logic JavaScript file, LeadCreator.js. Disclaimer: always test code in a non-production environment. For the Apex form, we have to manually fetch metadata. Here we use the UI API to get the valid pick list options for the status field, making our form more robust. This is the LDS handler. It is simple: on a successful save, the platform gives us the record details, and we show a toast. We then have to find the form element and call reset parentheses to clear it for the next entry. This is the Apex handler. It is much more involved. It includes client-side validation, setting a loading spinner, making an imperative Apex call with async or await, and handling success or error/finally blocks. This is the imperative call to our Apex method. We pass the JavaScript object we have been building. The try or catch block is essential for error handling. Here is the configuration XML file, leadcreator.jsmeta.xml. Disclaimer: always test code in a non-production environment. This tag makes our component visible and available to be used in tools like the Lightning App Builder. The target set configuration specifies exactly where this component can be placed by an administrator, making it flexible for various business needs. Here is the server-side logic Apex file, leadcreatorcontroller.cls. Disclaimer: always test code in a non-production environment. The method is exposed to LWC. We explicitly set cacheable equals false, which is a best practice for any method that performs a DML operation to prevent unexpected caching issues. This is the crucial security check. Unlike LDS, Apex does not respect CRUD or FLS by default. We must manually check if the user has permission to create a lead record before proceeding. When a security check fails or a DML error occurs, we throw an aura-handled exception. This is the correct exception type to use to send a clean, user-friendly error message back to the LWC's catch block. Here is the Apex test class file, leadCreatorControllerTest.cls. Disclaimer: always test code in a non-production environment. This annotation designates the class and its methods as part of a test suite. They do not count against org code limits and have access to special test methods. This block creates a fresh set of governor limits for the code being tested, which is a best practice for accurately testing Apex that might perform DML or make callouts. Assertions are the core of any test. Here we verify that the DML operation was successful by checking that the returned record now has a Salesforce ID. This demonstrates how to test for negative outcomes. We intentionally pass invalid data and then assert that our controller method correctly caught the error and threw the specific aura-handled exception we expect. Follow-up questions, from junior to senior. Follow-up question 1. Under what specific circumstances would you choose the Apex approach over the LDS approach, even if it is more work? Answer: I would choose Apex when I have business requirements that go beyond a simple record create. The top 3 reasons are: 1. Complex logic. If creating a lead also requires creating a follow-up task, updating a campaign member status, or calling an external system, Apex is required. 2. Custom validation. If I need validation logic that spans multiple objects or cannot be expressed in a standard validation rule, for example, ensure no other lead from this company was created in the last 24 hours. 3. Overriding defaults. If I need to bypass certain automations or default behaviors that a standard UI save would trigger, a custom Apex transaction gives me that control. Follow-up question 2. Your Apex FLS check is good, but what if an admin adds a new required field to the lead layout? How could your component fail and how would you prevent that? Answer: that's an excellent point about brittleness. If a new required field is added, the custom Apex form would not know about it, and the insert lead call would fail with a DML exception. The LDS form, however, would automatically adapt. To make the Apex approach more robust, I would use dynamic Apex and the UI API to fetch the required fields for the lead object's layout at runtime and dynamically render Lightning input components for each one. This makes the component more maintainable and less likely to break due to administrative changes. What the interviewer is really looking for. Architectural judgment. Do you know the pros and cons of LDS versus Apex? Do you default to the simplest, most secure option, LDS, first? Security mindset. When you write custom Apex for DML, do you immediately and correctly implement manual checks for CRUD and FLS? Robustness. Do you handle loading states, is loading, provide clear user feedback, toasts, and write code that can gracefully handle errors, try or catch/finally. Testing proficiency. Can you write both positive and negative test cases for your Apex code, demonstrating you know how to verify success and failure paths? Your turn, the practice challenge. Enhance the custom Apex part of the component. Add a checkbox labeled Create Follow-up Task. If the user checks it, your Apex method should not only create the lead but also create a related task record assigned to the current user with a subject like Follow Up with, lead name, and a due date of 7 days from today. This is a perfect example of a requirement that mandates the use of Apex.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.
LWC Coding Challenge 5, the Multi-Component State Manager, LMS. Question: what is this challenge and why does it matter? Answer: this challenge directly tests the ability to build a scalable and decoupled front-end architecture. The Lightning Message Service, LMS, is Salesforce's standard for communication between components that are not in a direct parent-child relationship, for example, siblings on a page, or a component in a utility bar and a component on the main page. Acing this proves you understand how to manage application state across different parts of a UI without creating a brittle, tightly coupled mess. It also critically tests your knowledge of lifecycle hooks, connected callback, disconnected callback, to prevent memory leaks, a non-negotiable professional skill. The challenge and interview timebox. The task: an interviewer asks you to build 2 separate components. The first component, Category Selector, displays a list of product categories. When a user clicks a category, the second component, Product Display, which is on the same page but not a child, must update to show only the products in that selected category. This communication must happen via LMS. Realistic time allocation, core coding task, live 20 to 25 minutes. Full interview discussion, with follow-ups can extend to 35 to 40 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, a great use case for LMS to facilitate communication between sibling components. My understanding is I will need to create a message channel, a publisher component to send a category ID, and a subscriber component that listens for that ID and then fetches the relevant data. A key part of this will be managing the subscription lifecycle to prevent memory leaks. 2. State your plan. I will start by defining the contract, the message channel itself. Then I will build the publisher component, which is fairly simple. After that, I will build the subscriber, which is more involved. It will need to subscribe in connected callback, handle incoming messages, call Apex to get data, and, crucially, unsubscribe in disconnected callback. Finally, I will write the Apex controller and its test class. 3. Code and narrate. As you code, explain the why. First, I'm creating the message channel. This is the radio station our components will tune into. Now in the subscriber, I'm calling subscribe inside connected callback. This ensures the component is listening as soon as it is on the page. And here's the most important part, calling unsubscribe in disconnected callback. If I do not do this, the component could try to handle messages even after it has been removed from the DOM, leading to errors and memory leaks. The component bundle, files we will create. 1. Category filter channel.messagechannelmeta.xml, the LMS communication channel. 2. Category selector component, the publisher, HTML, JS, meta. 3. Product display component, the subscriber, HTML, JS, meta. 4. Product controller.cls, Apex to fetch product data. 5. Product controller test.cls, the test class for our Apex. Here is the message channel file, category filter channel.messagechannelmeta.xml. Disclaimer: always test code in a non-production environment. This makes the message channel available for components in any namespace to use. It is required for cross-component communication. Defining Lightning message fields is a best practice. It clarifies the shape of the data being sent over the channel, similar to defining an API contract. Here is the publisher UI HTML file, category selector.html. Disclaimer: always test code in a non-production environment. Each button has a data ID attribute that holds the category value we want to send. The onClick event triggers our publish logic. Here is the publisher logic JavaScript file, category selector.js. Disclaimer: always test code in a non-production environment. We import the publish function and message context adapter from the Lightning or message service module. We import a reference to our message channel, which we can then use in our code. The __c suffix is required. We use the @wire service to get the message context, which is an object that provides information about the LWC that is using the LMS. This is the core publishing action. We call the publish function with the context, the channel we are broadcasting on, and the data payload. Here is the publisher configuration file, category selector.jsmeta.xml. Disclaimer: always test code in a non-production environment. This makes the component visible in the Lightning App Builder so it can be placed on a page. We target app pages to allow an admin to place this component and the subscriber component side by side to demonstrate the functionality. Here is the subscriber UI HTML file, productdisplay.html. Disclaimer: always test code in a non-production environment. The UI reactively displays the selected category property, which is updated by the LMS message handler in the JavaScript. This template uses a getter showDefault message to ensure this text only appears when there are no products and no error message, preventing conflicting UI states. Here is the subscriber logic JavaScript file, productdisplay.js. Disclaimer: always test code in a non-production environment. The subscriber imports subscribe and unsubscribe. Application_scope makes it listen for messages from the entire application, not just a specific active tab. This getter provides clean, robust logic for the template. It ensures the default message is only shown when there is no data and no error to display. Using the connected callback lifecycle hook, we immediately subscribe to the message channel as soon as the component is added to the DOM. This callback function is executed whenever a message is received on the channel. It extracts the payload and triggers the Apex call to refresh the product data. This is the most critical part for preventing memory leaks. When the component is removed from the DOM, we clean up by calling unsubscribe with our stored subscription object. Here is the subscriber configuration file, productdisplay.jsmeta.xml. Disclaimer: always test code in a non-production environment. This makes the component visible in the Lightning App Builder so it can be placed on a page. We target app pages to allow an admin to place this component and the publisher component side by side to demonstrate the functionality. Here is the Apex controller file, productcontroller.cls. Disclaimer: always test code in a non-production environment. This is a robust, top-level security check. Before even attempting to query, we verify the user has object-level access, failing fast if they do not. This keyword enforces field-level security on top of the object-level check, ensuring the user can only see the fields they are permitted to see. Here is the Apex test class file, productcontrollertest.cls. Disclaimer: always test code in a non-production environment. Using a test setup is a best practice. It creates a common set of test records once, which can then be used by all test methods in the class, making tests faster and more efficient. We assert that the method returns the correct number of records for a category that exists, testing the positive path. We also test the negative path by querying for a category with no products, ensuring the method behaves correctly and returns an empty list. Follow-up questions, from junior to senior. Follow-up question 1. What is the difference between Lightning Message Service and the older PubSub module some developers use? Answer. The PubSub module is an unofficial, LWC-only eventing library that works well for communication between LWCs on the same page. LMS is the official, Salesforce-supported framework. The key difference is scope. LMS can communicate across the DOM, meaning it works between LWC, Aura, and even Visualforce pages embedded in a Lightning page. For any new development, LMS is the standard and recommended approach. Follow-up question 2. When would you use a standard custom event instead of LMS? Answer. I would always use a standard custom event for parent-child or child-to-parent communication. Events are simpler, more direct, and specifically designed for components within a containment hierarchy. LMS should be reserved for cases where components have no direct relationship, when events would have to bubble up many levels or be broadcast down, which is an anti-pattern. Follow-up question 3. Curveball: a user opens 2 browser tabs for the same Salesforce org. If you publish a message in tab A, will the subscriber in tab B receive it? Why or why not? Answer. No, it will not. Lightning Message Service operates within a single browser tab's user interface. It is a front-end messaging system scoped to a single window or application instance. To communicate across different browser tabs or windows, you would need a different mechanism, like the Lightning or EMP API module to subscribe to a platform event, which operates on the server side. What the interviewer is really looking for. Architectural choice. Do you know when to use LMS, decoupled components, versus when to use events, parent-child? Lifecycle management. Did you immediately implement unsubscribe and disconnected callback? This is a huge sign of a professional developer. Attention to detail. Did you correctly import all the LMS functions and reference the message channel with the __c suffix? Understanding scope. Can you articulate the difference between LMS and other communication patterns like platform events? Your turn, the practice challenge. Enhance the category selector component. Add a clear filter button. When clicked, it should publish a message with a null or empty category ID. Modify the product display component's handleMessage function to check for this null value. If it receives a null category ID, it should clear the current product list and display the default select a category. Message. LWC Coding Challenge 6, the Security-Aware CRUD or FLS form, intermediate level. Question. What is this challenge and why does it matter? Answer. This challenge is a direct test of a developer's understanding of the Salesforce security model. While Lightning Data Service, LDS, provides security for free, any custom Apex DML operation bypasses it. This task proves a developer will not introduce security vulnerabilities into an org. Acing this demonstrates mastery of manual CRUD, create, read, update, delete, and FLS, field-level security, checks using the Apex schema class. It is a non-negotiable skill that separates a junior developer from an experienced professional who can be trusted with sensitive data. The challenge and interview time box. The task: an interviewer asks you to build a component to be placed on an opportunity record page. It should display a form to edit the opportunity's name, amount, stage, and close date. The key requirement is that the Apex controller handling the save operation must explicitly verify that the running user has permission to update the opportunity object and each of those specific fields before performing the DML. Realistic time allocation, core coding task, live 20 to 25 minutes. Full interview discussion, with follow-ups can extend to 40 to 45 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, this is a critical topic. A custom form for updates means we are responsible for security. My understanding is you want to see a component that gets the current opportunity data, allows edits, and then calls an imperative Apex method to save. The most important part will be that Apex method, where I will use schema methods like isUpdatable parentheses to manually and dynamically enforce FLS before the DML. 2. State your plan. I will start with the Apex controller, creating two methods, one cacheable method to securely fetch the initial opportunity data, and a second, non-cacheable method to handle the update. This update method is where I will implement the explicit and dynamic CRUD or FLS checks. Then, I will build the LWC to wire the initial data, display the form, and call the update method imperatively on save. Finally, I will write the Apex test class, including a run-as test to prove the security works. 3. Code and narrate. As you code the Apex, be very explicit. Here in my update opportunity method, my first check is isUpdatable parentheses at the object level. Then, instead of hard-coding field names, I'm dynamically iterating through the fields sent from the client using getPopulated_fields_as_map parentheses. This makes the method reusable and ensures I check permissions for every field in the update request. This is the most robust way to prevent security bypasses. The component bundle, files we will create. 1. OpportunityUpdater.html, the UI for the edit form. 2. OpportunityUpdater.js, logic to fetch data, handle changes, and save. 3. OpportunityUpdater.jsmeta.xml, configuration for the opportunity record page. 4. OpportunityUpdateController.cls, Apex with secure fetch and dynamic update methods. 5. OpportunityUpdateControllerTest.cls, the test class for our Apex, including run-as. Here is the user interface HTML file, OpportunityUpdater.html. Disclaimer: always test code in a non-production environment. The form is only rendered after the @wire service has successfully fetched the initial opportunity data, preventing errors from displaying an empty form. Each input is bound to a specific property in the JavaScript. We use individual handlers, handle name change, etc., to update a draft version of the record, keeping the original wired data pristine. The save button calls our handleSave function. It is disabled while isLoading is true to prevent the user from clicking it multiple times during a save operation. Here is the core logic JavaScript file, OpportunityUpdater.js. Disclaimer: always test code in a non-production environment. We wire the result to a function so we can store it in a property, wired_result. This is necessary to pass the result to refresh Apex after a successful save. We initialize an empty draft record object. The onChange handlers will populate this object with only the fields the user has changed. This is efficient and prevents sending unchanged data back to the server. After a successful save, we call refresh Apex with the stored result of our wire. This tells LWC to refetch the data, providing immediate UI feedback to the user that their changes were saved. This robust error handling uses optional chaining and a fallback message to ensure a user-friendly error is shown even if the error structure from Apex is unexpected. Here is the configuration XML file, OpportunityUpdater.jsmeta.xml. Disclaimer: always test code in a non-production environment. We specify that this component is designed to be placed on a record page. The target config restricts this component to only be available on opportunity record pages, preventing admins from placing it where it would not work. Here is the server-side logic Apex file, OpportunityUpdateController.cls. Disclaimer: always test code in a non-production environment. The update method is explicitly not cacheable, which is required for any method performing DML. This is the crucial first check. We verify the user has the permission to update the opportunity object at a general level before proceeding to field-level checks. This is the dynamic FLS check. We iterate over only the fields that were populated by the LWC, making the method efficient and reusable. Inside the loop, we get the field's metadata from the field map and check its isUpdatable property. If the user lacks permission, we throw an exception, preventing the DML operation entirely. Here is the Apex test class file, Opportunity Update Controller Test.cls. Disclaimer: always test code in a non-production environment. We create a sample opportunity record once that can be used by all test methods in the class for efficiency. To test a successful update, we call the method and then requery the database to assert that the change was correctly persisted. This is the gold standard for testing security. We create a user with a restricted profile and run the DML operation as that user. Inside the run as block, we assert that our Apex controller correctly identified the FLS violation for the restricted user and through our specific, user-friendly exception. This proves our security logic works. Follow-up questions, from junior to senior. Follow-up question 1, in the getOpportunity method, you used with security_enforced. Why did not you use that in the updateOpportunity method? Answer: with security_enforced is a fantastic tool for read operations, SOQL queries, as it automatically enforces FLS on the fields being queried. However, it has no effect on DML operations like update. When you are performing DML, you are no longer reading data, you are writing it, and Salesforce requires you to perform your own explicit, manual checks using the schema class methods, is updatable, is creatable, etc., to ensure security. Follow-up question 2, why not just use Lightning Record Form for this? It handles all the security for you automatically. Answer: you are absolutely right, for a simple edit form, Lightning Record Form is the superior choice precisely because it handles all CRUD or FLS checks for you. You would choose this custom Apex approach only when you have requirements that the standard component cannot meet. For example, if updating the opportunity also required creating a task, calling a web service, or performing complex validation logic that involves other records, you would need a custom Apex controller. In those cases, you take on the responsibility of enforcing security manually, as we have done here. Follow-up question 3, curveball: your dynamic Apex check is great, but could a user bypass it by sending a field they do not have access to see in the first place? How does getPopulated fields as map parentheses interact with data the user should not have? Answer: that's an excellent security question. The user cannot bypass the check because of the secure design of our getter method. The initial query in getOpportunity uses with security_enforced. This means the data sent to the LWC in the first place is already stripped of any fields the user cannot see. The user's browser never receives data for fields they do not have read access to. Therefore, when they submit the draft record back, it can only contain fields they were allowed to see and edit initially. Our updateOpportunity method then provides a second layer of defense by checking isUpdatable permissions on those fields. What the interviewer is really looking for. Security-first mindset: did you immediately identify the need for manual security checks without being prompted? Knowledge of the schema class: can you correctly use isAccessible, isUpdatable, and other schema methods dynamically? Architectural awareness: do you know when to use custom Apex, for complex logic, versus standard LDS components, for simplicity and security? Professional testing: do you know that system.run as parentheses is the correct way to validate that security rules are being enforced for different user profiles? Your turn, the practice challenge. Add a feature to the component that displays a read-only list of fields the current user is not allowed to edit. In your LWC's JavaScript, call a new Apex method that returns a list of field API names from your form, name, amount, stage name, close date, for which isUpdatable parentheses is false. Then, render a message like, note, you do not have permission to edit the following fields, amount, stage name.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your Salesforce jobs interviews like Salesforce LWC Developer jobs, Salesforce Technical Architect jobs, Salesforce Solution Architect jobs, Salesforce Service Cloud Consultant or Specialist jobs, Salesforce Test Engineer jobs, Salesforce DevOps Engineer jobs, Salesforce Marketing Cloud Developer. or consultant or specialist jobs, Salesforce admin jobs, Salesforce developer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based interview questions and answers, real-world problem-solving interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
LWC Coding Challenge 7, the API Data Display, Advanced Level. Question: what is this challenge and why does it matter? Answer: this is a quintessential senior developer task. Virtually every complex Salesforce implementation needs to integrate with external systems. This challenge tests a developer's ability to manage the entire lifecycle of an external data request, making the callout securely, handling asynchronous responses, safely parsing unpredictable data, and managing various failure modes. Acing this proves you can be trusted to build the connective tissue of an enterprise system, which is a high-value skill. It also specifically tests knowledge of Apex callout limits, mock testing, and the critical choice between remote site settings and named credentials. The challenge and interview timebox. The task: an interviewer asks you to build a component that fetches a list of users from a public REST API, https://johnplaceholder.typicode.com or users. The component should have a button to trigger the fetch, display a loading spinner while waiting, and then render the user's name, email, and city in a list. The solution must include robust error handling and a proper Apex test class using a callout mock. Realistic time allocation: core coding task, live 25 to 30 minutes. Full interview discussion, with follow-ups can extend to 45 to 50 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, great, an external API integration. This will test the full async flow. To confirm, I will use an imperative Apex call from the LWC to a method that performs the HTTP GET callout. For robust data handling, I will create an Apex wrapper class to deserialize the JSON response. The most critical part will be the test class, where I will implement the HTTP callout mock interface to simulate the API response without making a real callout during tests. 2. State your plan. I will start with the Apex side first, as it defines the data contract. This includes the wrapper class for the JSON structure, the callout method itself, and then immediately writing the test class with the callout mock. Once the backend is proven to work, I will build the LWC to call this method, manage the loading state, and render the results or any errors. 3. Code and narrate. Be very deliberate with your language. First, I'm creating this user wrapper class. Using a typed class instead of a generic map for JSON.deserialize makes the code strongly typed, easier to debug, and less prone to runtime errors. Now for the test, I'm implementing HTTP callout mock. This is mandatory for testing callouts, as Salesforce tests cannot make real external calls. This mock allows me to define the exact response body and status code to ensure my parsing logic works for both success and failure cases. In the LWC, I'm using the try or catch/finally block for the imperative call. The finally block is key to ensuring the spinner is always turned off, even if the callout fails. The component bundle, files we will create. 1. API data display.html, the UI with a fetch button, spinner, and result list. 2. API data display.js, the client-side logic to trigger the call and handle state. 3. API data display.js meta.xml, configuration to expose the component. 4. External API controller.cls, the Apex controller with the callout logic and wrapper class. 5. External API controller test.cls, the crucial Apex test class with a mock implementation. Here is the user interface HTML file, API data display.html. Disclaimer: always test code in a non-production environment. A simple button with an on-click handler. The callout is user-initiated, which is a perfect use case for an imperative Apex call. Conditional rendering of a spinner provides essential user feedback during the asynchronous callout, preventing the user from thinking the application is frozen. The error message is displayed conditionally. The role equals alert attribute is included for accessibility, ensuring screen readers announce the error to the user. Here is the core logic JavaScript file, API data display.js. Disclaimer: always test code in a non-production environment. The handler is marked async, allowing the use of the await keyword for cleaner, more readable asynchronous code compared to older promise chaining. Before making the call, we reset the component's state. This is crucial for retries, ensuring old data or errors are cleared from the screen. This is the imperative call to our Apex method. The await keyword pauses the function's execution until the promise from the Apex call resolves. The try or catch/finally block provides robust state management. The catch block handles failures, and the finally block always executes, guaranteeing the spinner is hidden. Here is the server-side logic Apex file, external API controller.cls. Disclaimer: always test code in a non-production environment. Crucially, the method is marked cacheable equals false. Salesforce does not allow methods that perform callouts to be cached on the client, so this is mandatory. We explicitly note that hard-coding the endpoint is for demonstration purposes only. The enterprise-grade best practice is to use a named credential. On success, we deserialize the raw JSON string from the response body into a strongly typed list of our custom user wrapper objects. This is much safer than using untyped maps. When the callout fails, we throw an exception that includes not just the status, but also the response body. This gives the front end and logs much more context for debugging. Here is the Apex test class file, external API controller test.cls. Disclaimer: always test code in a non-production environment. This is the core of callout testing. We tell the Apex test runner to intercept any callout and return our predefined mock response instead of making a real HTTP request. We create a reusable inner class that implements the HTTP callout mock interface. This requires us to define a respond method that returns a crafted HTTP response. For the failure test, we set up a mock that returns a non-200 status code, then we call our method inside a try or catch block and assert that our controller correctly threw the expected exception. Here is the configuration XML file, API data display.js meta.xml. Disclaimer: always test code in a non-production environment. This makes the component visible in the Lightning App Builder so it can be placed on a page for use. Follow-up questions, from junior to senior. Follow-up question 1. Your code uses a hard-coded URL. In a real project, this would need to be authorized. What is the difference between remote site settings and named credentials, and which should you use? Answer: remote site settings is the older mechanism. It is a simple allow list that tells Salesforce, it is okay to make a callout to this URL, it does not handle authentication. Named credentials is the modern best practice. It combines the URL with authentication details, like an API key or OAuth 2.0 flow, into a single, secure, and manageable entity. Crucially, code references the named credential, not the URL. This allows admins to update the endpoint URL in production versus a sandbox without any code changes, making it far superior for enterprise development. Follow-up question 2, the external API is very slow, and the user is seeing the spinner for a long time, which sometimes causes a CPU limit error in Salesforce. How would you re-architect this solution? Answer: this is a classic issue with synchronous callouts. The best solution is to make it asynchronous. I would change the apex method to be a at future, callout equals true, method. The LWC would call an initial apex method that kicks off this future job and returns immediately. The LWC would then subscribe to a platform event or a custom streaming API channel. When the future method completes its slow callout, it would publish a platform event with the results. The LWC, listening for this event, would then update the UI. This decouples the UI from the long-running process, providing a much better user experience and avoiding governor limit issues. Follow-up question 3, curveball: what if the JSON response from the API sometimes omits a field, like address is null for some users? How would your current Apex code behave, and how could you make it more resilient? Answer: my current code would fail. The JSON.deserialize call into the strongly typed wrapper class would throw a system.json exception if it expects the address node but it is missing. To make it more resilient, the best approach is to first deserialize into a more flexible structure, like list map string object. Then, I would manually iterate through this list of maps, constructing my user wrapper objects in Apex code. In the loop, I can check if the map contains key, address, and is not null before trying to access it. This adds a layer of defensive programming and makes the solution resilient to minor, non-breaking changes in the external API's response. What the interviewer is really looking for. Testing mastery: do you know that HTTP callout mock is not optional, and can you implement it correctly for both success and failure cases? Data handling: do you use strongly typed wrapper classes instead of generic maps? Can you articulate the pros and cons? Asynchronous mindset: do you properly manage the loading state in the LWC and handle errors gracefully? Architectural knowledge: can you discuss advanced topics like named credentials versus remote site settings and synchronous versus asynchronous callout patterns, at future platform events? Your turn, the practice challenge. Modify the component to allow fetching a single user. Add a lightning input for the user ID. When the user enters an ID and clicks the button, call a new Apex method that makes a callout to https://johnplaceholder.typicode.com or user ID. You will need a new Apex method, a new callout, and logic in the LWC to handle displaying either a list or a single user. Ensure you also add a new test method with a mock for this new endpoint. LWC Coding Challenge 8, the Custom Data-Driven Progress Bar, Advanced Level. Question: what is this challenge and why does it matter? Answer: this challenge tests a developer's deep understanding of the LWC reactive rendering engine and modern front-end techniques. Building a simple bar is easy, building a reactive, data-driven, and reusable one is not. It tests the correct use of getters for computed properties, which is far more efficient than imperative DOM manipulation in a rendered callback. Acing this demonstrates that a developer can write performant, elegant UI components and understands how to bridge the gap between JavaScript logic and CSS for dynamic styling, a hallmark of a senior front-end specialist. The challenge and interview timebox. The task: an interviewer asks you to build a reusable progress bar component. It must accept a single public property, progress value, a number from 0, 100. The bar's width must dynamically update to match this percentage. Additionally, the bar's color should change, red for values below 50, orange for 50 to 99, and green for 100. Realistic time allocation: core coding task, live 15 to 20 minutes. Full interview discussion, with follow-ups can extend to 30 to 35 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify: great, a dynamic UI component. This is a perfect use case for LWC's reactive getters. My understanding is I will create a reusable child component that takes a percentage via an API property. I will make sure it is fully accessible with ARIA attributes. I will then use a getter in its JavaScript to compute the dynamic CSS styles for the width and color. I will also build a parent component with a slider to demonstrate the bar's reactivity in real time. 2. State your plan. I will start with the child component, progress bar. In the JavaScript, I will define the API property with a setter to ensure the value is always clamped between 0 and 100. Then, I will write the getter to calculate the style string. The HTML will include all necessary ARIA roles and attributes. The CSS will handle the BASE styling. After that, I will quickly build a progress bar demo parent to control and showcase the child component. 3. Code and narrate. As you code, explain your architectural choices. I'm using a getter here for the bar's style. This is a key LWC best practice. The framework knows this getter depends on the progress value property, so it will only re-evaluate and re-render the bar when progress value actually changes. This is much more performant than using a rendered callback. Notice I'm adding role equals progress bar and other ARIA attributes directly to the HTML. Building with accessibility from the start is a professional habit. The component bundle, files we will create. 1. Progress bar component, the reusable child component, HTML, JS, CSS, meta. 2. Progress bar demo component, a parent to demonstrate the progress bar, HTML, JS, meta. Here is the child component UI file, progressbar.html. Disclaimer, always test code in a non-production environment. These WARIA attributes are essential for accessibility. Role equals progress bar tells screen readers what the element is, while the ARIA-attributes provide the minimum, maximum, and current values so the user gets proper context. This is the actual bar that grows and changes color. Its style attribute is directly bound to a getter in our JavaScript, which is the core of LWC's reactive UI updates. Including assistive text provides a human-readable percentage for screen reader users, which is more descriptive than the ARIA-value attribute alone. Here is the child component logic file, progressbar.js. Disclaimer, always test code in a non-production environment. Using a setter on our public API property is a robust design pattern. It allows us to validate or sanitize the incoming value, in this case ensuring the progress is never less than 0 or greater than 100. This is the primary reactive getter. It depends on this .progress value. Whenever progress value changes, the LWC engine automatically re-evaluates this getter and updates the style attribute in the template. This is highly efficient. A helper function encapsulates the color logic, keeping the bar style getter clean and readable. It returns the appropriate color string based on the current progress. Here is the child component CSS file, progressbar.css. Disclaimer, always test code in a non-production environment. The container has overflow, hidden so that as the inner bar grows, it is neatly clipped within the rounded corners of the container. The transition property is key to a smooth user experience. Instead of the width and color snapping instantly to new values, this CSS rule tells the browser to animate the change over 0.3 seconds. Here is the child component meta file, progressbar.jsmeta.xml. Disclaimer, always test code in a non-production environment. We set is exposed to false. This is a best practice for utility components meant to be used inside other components, as it prevents cluttering the app builder. For isolated testing, a developer might temporarily set this to true. Here is the parent demo UI file, progressbardemo.html. Disclaimer, always test code in a non-production environment. We embed our child component. Its public progress value attribute, kebab case, is bound to the current progress property in our parent's JavaScript. We use a standard slider component to provide an interactive way to change the current progress value, which then flows down to the child component, demonstrating reactivity. Here is the parent demo logic file, progressbardemo.js. Disclaimer, always test code in a non-production environment. The parent component owns the state. It holds the current progress value that will be passed down to the child. When the slider's value changes, this handler updates the current progress property. The LWC framework detects this change and automatically passes the new value down to the progress bar child, triggering its reactive getters. Here is the parent demo meta file, progressbardemo.jsmeta.xml. Disclaimer: always test code in a non-production environment. The demo component is exposed so an admin can place it on a page to see the progress bar in action. Follow-up questions, from junior to senior. Follow-up question 1. Why did you use a getter for the style instead of calculating it and setting a property in the rendered callback lifecycle hook? Answer: using a getter is the LWC native, reactive way to handle this. The framework tracks the dependencies of the getter, in this case, this.progress value. It will only re-execute the getter, and thus trigger a re-render, when a dependency changes. Rendered callback, on the other hand, can fire multiple times during a render cycle and is not guaranteed to fire only when data changes. Using it for DOM manipulation is an anti-pattern and can lead to performance issues and infinite render loops. Getters are more declarative, predictable, and performant. Follow-up question 2, you have added ARIA roles to the component, which is great. What specific user experience does this enable? Answer: this directly impacts users of assistive technologies like screen readers. When a screen reader user navigates to this component, it will announce something like, progress bar, 25%. Without these roles, it would just announce it as a generic group or div, providing no context. The ARIA valueNo attribute is particularly important as it allows the user to query the current state of the bar at any time, which is essential for non-visual feedback on dynamic content. Follow-up question 3, curveball: instead of hard-coding colors in the JavaScript, how could you use CSS styling hooks to allow a parent component to override the bar's color? Answer: that's a more advanced and flexible approach. I would refactor the CSS for progress bar value to use a CSS variable, like background color, var, progress bar fill color, #0070d2. Then, in my progressbar.js, the bar style getter would no longer set the color directly. Instead, the parent component, progressbardemo.html, could set the color declaratively like this: C progress bar progress value equals, current progress, style equals, progress bar fill color, purple, /C progress bar. This fully decouples the color logic from the child component, making it much more reusable and themable. What the interviewer is really looking for. Reactivity knowledge: do you instinctively reach for getters to compute derived values instead of less efficient lifecycle hooks? Component architecture: can you build a truly reusable, dumb, child component that receives its state from a smart parent? Modern CSS skills: do you know how to use transitions for a smooth UX? Can you discuss advanced concepts like styling hooks? Accessibility first mindset: do you build accessibility, ARIA roles, into the component from the start, rather than treating it as an afterthought? Your turn, the practice challenge. Enhance the component by adding a visual percentage label centered inside the progress bar. The key is to make the label's text color dynamic to ensure it meets WCAG accessibility contrast ratios. In your JavaScript, create a new getter for a text color property that returns white for dark backgrounds, red, green, and black for light backgrounds, orange. This will prove you can manage multiple computed properties and are designing with accessibility in mind. LWC Coding Challenge 9, the Refactor This Challenge, Advanced Level. Question: what is this challenge and why does it matter? Answer: this challenge simulates a real-world code review, one of the most important responsibilities of a senior developer. It is not about writing code from scratch, but about critically analyzing existing code to identify flaws in performance, security, and maintainability. Acing this proves a developer possesses a deep understanding of platform best practices and governor limits. It shows they can not only build features but can also safeguard the long-term health of a code base, a skill that is invaluable to any technical team. The challenge and interview timebox. The task: An interviewer presents you with a seemingly functional LWC and Apex class that displays a list of opportunities and their account owner's name. They say, "This code works, but a junior developer wrote it and we are not happy with it. Please identify all the issues and then refactor it to meet our standards." Realistic time allocation, analysis phase, live 5 to 10 minutes, identifying issues. Refactoring task, live 20 to 25 minutes, rewriting the code. Full interview discussion, with follow-ups can extend to 45 to 50 minutes. How to ace the interview, your thought process. 1. Acknowledge and analyze first, understood. Before I write any new code, I'm going to analyze the existing solution and list out the specific issues I see in both the Apex and the LWC. This will form my refactoring plan. 2. Systematically list the problems. Okay, looking at the Apex, the most critical issue is the SOQL query inside a for loop, which will violate governor limits with more than 100 records. The class is also missing sharing keywords and FLS or CRUD checks, making it insecure. On the LWC side, there's no loading state feedback for the user, no error handling, and the data is rendered directly, which could cause issues if the Apex call fails. 3. State your refactoring plan. My plan is to refactor the Apex to use a single, efficient SOQL query that leverages relationship queries. I will add with sharing and with security _enforced. I will also create a wrapper class for a clean data contract. In the LWC, I will implement a proper loading state with a spinner, add a try or catch / finally block for robust error handling, and use conditional templates for a better user experience. The before code, the poorly written version. The before HTML, opportunity manager _bad.html. Disclaimer, always test code in a non-production environment. Problem, there is no conditional rendering. If the ops property is undefined or the Apex call fails, the UI will show nothing, and the user will not know if the system is broken or just slow. There is also no loading indicator. The before JS, opportunity manager _bad.js. Disclaimer, always test code in a non-production environment. Problem, the loadops function lacks any user feedback. It does not set a loading state, so the UI feels unresponsive. The catch block only logs the error to the console, it does not inform the user that something went wrong. Problem, swallowing errors is a major anti-pattern. The user has no idea that the operation failed. A proper implementation should display a user-friendly error message, for example, using a toast notification. The before Apex, opportunity controller _bad.cls. Disclaimer, always test code in a non-production environment. Problem, the class signature is missing with sharing. This means it runs in system mode and will ignore the user's record-level sharing rules, potentially leaking sensitive data. Problem, this is a SOQL query inside a for loop, the most critical performance anti-pattern on the platform. This code will fail if the initial query returns more than 100 opportunities. Problem, returning a list map string is not a best practice. It creates a weak data contract. The front end has no guarantee of what keys exist, and typos, owner name versus owner name, become runtime errors. A strongly typed wrapper class is far superior. The after code, the refactored version. The after HTML, opportunity manager _good.html. Disclaimer, always test code in a non-production environment. Improvement, proper conditional rendering provides clear user feedback. The spinner is shown during loading, and this error box, with role equals alert for accessibility, is shown on failure. Improvement, the template now binds to op.accountOwnerName, a descriptive property from our Apex wrapper class. This decouples the UI from the underlying SOQL structure and makes the code's intent clearer. The after JS, opportunity manager _good.js. Disclaimer, always test code in a non-production environment. Improvement, the component now tracks its own loading state with a dedicated Boolean property, allowing the UI to react accordingly. Improvement: the logic is wrapped in a try or catch/finally block. This provides robust error handling, showing a toast to the user, and guarantees that the isLoading spinner is turned off, even if the call fails. The after Apex opportunity controller _good.cls. Disclaimer: always test code in a non-production environment. Improvement: the class now includes with sharing, ensuring that it respects the current user's record-level sharing rules. Improvement: this is the most critical fix. We now use a single, efficient SOQL query that includes ID and traverses the relationship from opportunity up to account and then to its owner. With security _enforced is also added for FLS. Improvement: a strongly typed inner wrapper class provides a clean, reliable data contract for the LWC. This prevents bugs from typos and makes the code self-documenting and easier to maintain. Follow-up questions, from junior to senior. Follow-up question 1, you used at or enabled, cacheable equals true, but called the method imperatively from the LWC. What are the implications of this choice? Answer: this is a great question. Using cacheable equals true means the Lightning data service can cache the response on the client. Even though I'm calling it imperatively on a button click, if the user clicks the button a second time without a page refresh, the cached result will be returned almost instantly without a second server trip. This is great for performance. The trade-off is that the data could become stale. If I expected the underlying data to change frequently, I would need to implement the refresh Apex function in my LWC to invalidate the cache and force a new server call. Follow-up question 2, the refactored query account.owner.name is great. What if you needed to query down to a child record, like getting all related contact names for each opportunity? How would you do that efficiently? Answer: that would require a different approach, as you cannot put a child query inside the main for loop. The efficient, bulkified pattern would be, 1. Query all the parent opportunities. 2. Loop through them once to collect all their IDs into a set ID. 3. Perform a second, single query for all child contacts where the opportunity ID is in our set, select name, opportunity ID from contact where opportunity ID in, op ID set. 4. Loop through the returned contacts and organize them into a map ID, list contact, where the key is the opportunity ID. Finally, I would combine the data in my wrapper class. Follow-up question 3, curveball: you used a wrapper class. Why is that better than just returning the list opportunity directly and letting the LWC use op.account.owner.name in the template? Answer: while that would work visually, using a wrapper class is a better architectural pattern for a few reasons. First, it creates a data transfer object, DTO, that decouples the front end from the back end's SOQL structure. If I later need to get the owner's name from a different object, I can change the Apex logic, but as long as I populate the account owner name property, the LWC does not need to change. Second, it is more performant for complex data, as it can preprocess and flatten data in Apex, sending a cleaner, simpler JSON payload to the client. It keeps the LWC dumber and the Apex smarter, which is a solid design principle. What the interviewer is really looking for. Problem identification: can you spot common anti-patterns, SOQL in loops, and security vulnerabilities, missing with sharing, immediately? Knowledge of best practices: do you know the correct way to solve the problem using relationship queries, wrapper classes, and proper LWC state management? Performance and limits: do you understand why the bad code is bad? Can you explain governor limits and the impact of bulkification? Communication: can you clearly articulate the problems and then explain the benefits of your proposed solutions? Your turn, the practice challenge. Enhance the refactored good code. Add a new requirement: for each opportunity, display the name of the primary contact associated with it. This will require you to apply the efficient child query pattern, as discussed in the follow-ups, to fetch related opportunity contact role records where isPrimary equals true. Extend the wrapper class with a new primary contact name property to hold this data.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your Salesforce jobs interviews like Salesforce LWC Developer jobs, Salesforce Technical Architect jobs, Salesforce Solution Architect jobs, Salesforce Service Cloud Consultant or Specialist jobs, Salesforce Test Engineer jobs, Salesforce DevOps Engineer jobs, Salesforce Marketing Cloud Developer or Consultant or Specialist jobs, Salesforce Admin jobs, Salesforce Developer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based interview questions and answers, real-world problem-solving interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
LWC Coding Challenge 10, the Dynamic Form Builder, Advanced Level. Question: what is this challenge and why does it matter? Answer: this challenge tests a developer's ability to build truly flexible and future-proof components. Instead of hard-coding fields, a dynamic form reads a list of field names and renders the appropriate inputs at runtime. This is the cornerstone of creating admin configurable components. Acing this demonstrates mastery of the UI API wire adapters to fetch both record data, getRecord, and object metadata, getObjectInfo, advanced template directives, and the ability to write generic JavaScript that can handle data from any field without being explicitly coded for it. The challenge and interview timebox. The task: an interviewer asks you to build a component that can render an input form for any given subject. The component should accept a public API record ID and a comma-separated string of field API names. It must then fetch the necessary metadata and record data to display the correct labels and current values for those fields in Lightning input components. It should also have a save button to update the record. Realistic time allocation: core coding task, live 25 to 30 minutes. Full interview discussion, with follow-ups can extend to 45 to 50 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, a metadata-driven component. This is a powerful pattern. To confirm, I will create a single component that takes a record ID and a string of field names. The key will be to use 2 UI API wire adapters, getRecord for the data, and getObjectInfo for the field labels and metadata. This ensures the form is always accurate. For simplicity in this timebox, I will use Lightning input and assume the fields are standard text or number/email types. 2. State your plan. My approach will be JavaScript-centric. I will define the API properties and set up both wire adapters. The magic happens in the getRecord wires handler function, where I will wait for both data and metadata to be available. Then, I will transform this raw information into a clean array of field objects that my HTML template can easily iterate over. Finally, I will build the HTML template, wire up a generic save handler, and add logic to disable the save button until a change is made. 3. Code and narrate. As you code, explain the data transformation. The UI API gives us 2 separate objects for data and metadata. The crucial step is this transformation logic here. I'm mapping over my list of field names, and for each one, I'm plucking the label from the getObjectInfo response and the value from the getRecord response. This creates a simple fields array, which keeps my HTML template clean. This separation of concerns is a core LWC best practice. The component bundle, files we will create. 1. Dynamic Form Builder.html, the UI that iterates and renders the fields. 2. Dynamic Form Builder.js, the logic to fetch metadata, transform data, and handle saves. 3. Dynamic Form Builder.js meta.xml, configuration to expose the component and define its properties. Here is the user interface HTML file, Dynamic Form Builder.html. Disclaimer: always test code in a non-production environment. This is the dynamic part. The label and value are bound to properties of the field object we created in JavaScript. The data field attribute is crucial for our generic onChange handler to know which field is being updated. The Save button's disabled attribute is bound to a getter. This provides a better user experience by preventing saves when no data has changed or when a save is already in progress. Here is the core logic JavaScript file, Dynamic Form Builder.js. Disclaimer: always test code in a non-production environment. We add a second wire adapter, getObjectInfo. This fetches all the metadata for the object, including the correct labels for every field. In the getRecordWire handler, we now wait for both the record data and the object metadata to be loaded. This prevents race conditions and ensures we have everything needed to build the form. This is the corrected label logic. We now pull the proper label from the ObjectInfo data response, providing an accurate and professional UI. This new getter controls the Save button state. It is disabled if the component is already saving, is loading, or if no fields have been changed, is dirty, improving the user experience. This dedicated error handler inspects the error structure from the wire service. It specifically looks for invalid field errors and provides a clear, actionable message to the admin. Here is the configuration XML file, Dynamic Form Builder.js meta.xml. Disclaimer: always test code in a non-production environment. The target config section is essential for this component. It is what makes the component configurable by an administrator in the Lightning App Builder. We define properties for Object API Name and Field API Names. This exposes them as input fields in the App Builder, allowing an admin to drag the component onto a contact page and enter first name, last name, email, and then drag the same component onto an account page and enter name, industry, phone. Follow-up questions, from junior to senior. Follow-up question 1. This implementation only uses Lightning input. How would you enhance it to support other field types like pick lists or date fields? Answer: that's the natural next step for a robust version. In the ObjectInfo data that we are now fetching, each field's metadata includes its data type, for example, pick list, date, boolean. I would add this data type to my transformed fields array. Then, in the HTML template, I would use conditional rendering, if true/if false, inside the loop to render a Lightning combo box if the type is pick list, a Lightning input type equals date if it is a date, and so on. This would require more complex data preparation in the JavaScript, like fetching picklist values using the getPicklistValues wire adapter. Follow-up question 2, you are using Lightning Data Service, getRecord, updateRecord. What is the main security advantage of this approach compared to using a custom Apex controller? Answer: the primary advantage is that Lightning Data Service, LDS, automatically and transparently enforces all Salesforce security and sharing rules. When I call getRecord, it will only return data for fields the user has read access to, FLS. Similarly, the updateRecord call will fail if the user does not have edit access on the object, CRUD, or specific fields. With a custom Apex controller, I would be responsible for manually implementing these checks using isAccessible parentheses and isUpdatable parentheses methods, as we did in the Security-Aware Form Challenge. LDS gives you that security for free. Follow-up question 3, curveball: an admin adds this component to a page and enters a field API name with a typo, for example, email, instead of email. How does your improved code handle this? Answer: My refactored code now handles this gracefully. The getRecordWire adapter returns a specific error when a field does not exist. My custom handleError function inspects that error object, looking for the telltale invalid field message. When it finds it, instead of showing a generic failure, it displays a specific, user-friendly message, configuration error, an invalid field API name was provided. This provides actionable feedback directly to the administrator to help them fix the configuration without needing to check the browser console. What the interviewer is really looking for. Knowledge of the UI API. Do you know to use both getRecord, for data, and getObjectInfo, for metadata, to build a complete and accurate UI? Data transformation skills. Can you take multiple complex API responses and reshape them into a simple data structure that's easy for a template to render? Robust UX or error handling. Do you think about disabled states, loading indicators, and providing clear, actionable error messages for different failure scenarios? Architectural awareness. Can you articulate the security and maintenance benefits of using LDS over custom Apex for this specific use case? Your turn, the practice challenge. Enhance this component to support read-only fields. Modify the .js meta.xml to accept a second string property called read-only field API names. In your JavaScript, add logic so that any field whose API name is in this second list is rendered as read-only in the Lightning input component. This tests your ability to manage and merge multiple configuration properties into a single UI. LWC Coding Challenge 11, the Composable Card Component, Advanced Level. Question: what is this challenge and why does it matter? Answer: this challenge tests a developer's ability to think architecturally. Instead of building one monolithic component, the goal is to create small, reusable, dumb components that are orchestrated by a smart parent. This pattern, known as component composition, is the key to building scalable and maintainable front ends. Acing this proves you understand how to manage a one-to-many relationship, one parent, many children, pass data down effectively, and handle events bubbling up from a specific child within a list. It is a direct measure of a developer's front-end maturity. The challenge and interview timebox. The task: an interviewer asks you to build a component that displays a list of hot opportunities, for example, stage is not closed won or closed lost. The parent component is responsible for querying the data. However, each opportunity in the list must be rendered by a separate, reusable opportunity card child component. When a user clicks a button on any card, the parent component must be notified and display the ID of the selected opportunity. Realistic time allocation, core coding task, live 20 to 25 minutes. Full interview discussion, with follow-ups can extend to 40 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, a component composition challenge. This is a great pattern for reusable UIs. So, the parent component will be the smart one, handling the Apex data query. It will then use a for each loop to render a dumb opportunity card child for each record. The child will just be responsible for displaying the data it receives and firing an event with its ID when a user interacts with it. 2. State your plan. I will start by building the child opportunity card component first. It is the simplest piece. It will have an API property to accept an opportunity record and a handler to dispatch a custom event. Then I will write the simple, cacheable Apex method and its test class. Finally, I will build the parent opportunity list component to wire up the Apex method, iterate over the results, pass each record to a child card, and handle the event bubbling up. 3. Code and narrate. As you code, explain the data and event flow. In the parent's loop, I'm passing the entire op object down to the child via the opportunity public property. This is data down. Now, in the child's handleSelect function, I'm dispatching a custom event named select. The crucial part is the detail payload, which contains this .opportunity.id. This is events up. Back in the parent, the handleSelect function receives this event and can now identify exactly which child card was clicked by accessing event.detail. The component bundle, Files we will create. 1. Opportunity card component, the reusable child card, HTML, JS, meta. 2. Opportunity list component, the smart parent container, HTML, JS, meta. 3. Opportunity controller.cls, the Apex class to query opportunity data. 4. Opportunity controller test.cls, the test class for the Apex method. Here is the child component UI file, opportunitycard.html. Disclaimer: always test code in a non-production environment. The child component is dumb, it simply renders data from the opportunity property that is passed down to it from the parent. The button's onClick handler will trigger the custom event that notifies the parent of a user interaction. Here is the child component logic file, opportunitycard.js. Disclaimer: always test code in a non-production environment. The @API decorator makes the opportunity property public, allowing the parent component to pass a record object into it. This is the core of child-to-parent communication. We create a custom event and put the opportunity's ID in the detail property. The parent will listen for this event and use the ID to identify which card was selected. Here is the child component meta file, opportunitycard.jsmeta.xml. Disclaimer: always test code in a non-production environment. As a best practice, this reusable child component is not exposed to the app builder. It is designed to be used programmatically by its parent, not placed on a page by an admin. Here is the parent component UI file, opportunitylist.html. Disclaimer: always test code in a non-production environment. The parent component iterates through the list of opportunity records fetched from Apex. This is component composition in action. For each record, we create an instance of our child component, passing the op record down via the opportunity property and listening for the select event with the onSelect handler. Here is the parent component logic file, opportunitylist.js. Disclaimer: always test code in a non-production environment. The parent uses the @wire service to fetch the list of opportunities. The result object, containing either data or error, is stored in the opportunities property. This handler executes when any child card dispatches a select event. It accesses the ID from the event's detail payload and updates its own state, causing the UI to re-render and display the selected ID. Here is the parent component meta file, opportunitylist.jsmeta.xml. Disclaimer: always test code in a non-production environment. The parent component is exposed so that admins can drag and drop it into Lightning pages to make it visible to users. We define multiple targets to allow this component to be used flexibly across different types of pages in the application. Here is the Apex controller file, opportunitycontroller.cls. Disclaimer: always test code in a non-production environment. The method is cacheable, which is a requirement for using it with the @wire service in LWC. The SOQL query is efficient and secure. It fetches only the necessary fields for open opportunities, respects FLS with security _enforced, and limits the result set. Here is the Apex test class file, opportunitycontrollerTest.cls. Disclaimer: always test code in a non-production environment. The core logic is wrapped in test.status parentheses and test.stoptus parentheses to ensure it runs with a fresh set of governor limits. The assertion verifies that our controller method correctly queries and returns the test record we created. A more robust test would also verify the field values. Follow-up questions, from junior to senior. Follow-up question 1. Why is this compositional pattern better than just building one large component that queries the data and has all the HTML in a single file? Answer: there are two main reasons, reusability and maintainability. The opportunity card is now a reusable asset. I can use it anywhere in my application that needs to display a summary of an opportunity, not just in this list. For maintainability, if I need to change how an opportunity card looks, I only have to edit one small, focused component file. In a large, monolithic component, that same change might be buried in hundreds of lines of code, making it harder to find and riskier to edit. Follow-up question 2, in your child component, you did not include bubbles, true, in the custom event. When would you need to do that? Answer, that's a great question about event propagation. By default, custom events do not bubble up the DOM tree. This means only the immediate parent that has the listener, on select, can hear it. This is the desired and most common behavior for component composition. I would add bubbles, true, composed, true, only in rare cases where a grandparent or even a completely unrelated component higher up the DOM tree needs to listen for the event. This creates a tighter coupling and is generally avoided in favor of more explicit communication patterns like LMS. Follow-up question 3, curveball: a new requirement comes in, the parent needs a refresh button. How would you implement this to force the list of opportunities to update from the server? Answer, to do that, I would need to make 2 changes. First, in the JavaScript, I would change my wire from a property to a function, at wire, get hot opportunities, wired_ops, result, this dot opportunities equals result. This allows me to save the provisioned result object. Second, I would add a refresh button to the HTML with an onClick handler. That handler would then call the standard refreshApex function, passing it the saved result object, return refreshApex, this dot opportunities. This tells the LWC framework to bypass the client-side cache and refetch the data from the Apex controller. What the interviewer is really looking for. Architectural thinking: do you instinctively break down a large UI problem into smaller, reusable components? Data flow mastery: can you correctly implement the data down at API and events up custom event pattern? List handling: do you know how to handle an event from a specific item within a list and get its unique identifier? Reusability mindset: can you articulate the business and technical benefits of composition over monolithic design? Your turn, the practice challenge. Enhance the parent component. Add a sort by pick list with options for amount and close date. When the user changes the selection, requery the Apex method, passing the selected sort field as a parameter. The Apex method will need to be modified to use dynamic SOQL to handle the variable order by clause. This tests reactive wire parameters and secure dynamic Apex. LWC Coding Challenge 12, the interactive data table with inline editing, advanced level. Question: what is this challenge and why does it matter? Answer: this challenge is the practical evolution of a simple data display, building directly on the read-only data table from challenge number 2. It tests a developer's ability to handle complex UI state and bulk data operations. While displaying data is fundamental, businesses almost always need to edit it efficiently. Acing this proves mastery over the intricate Lightning Datatable events, the management of the draft value state object, and the ability to write a secure, bulkified Apex method that can handle partial successes or failures. This is a common, high-value requirement that separates developers who can build displays from those who can build real, interactive applications. The challenge and interview timebox. The task: an interviewer asks you to build a component that displays a list of related contacts for an account in a Lightning Datatable. The key requirement is that the name and email fields must be editable directly in the table. The user should be able to edit multiple rows and then click a single Save button to commit all changes at once. The component must provide clear feedback on success or failure. Realistic time allocation: core coding task, live 25 to 30 minutes. Full interview discussion, with follow-ups can extend to 45 to 50 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, an inline editing data table. This is a great test of managing client-side state and bulk DML. So, the plan is to fetch related contacts using a wired Apex call. I will configure the data table columns to be editable, which will automatically enable the save and cancel buttons. The core of the LWC logic will be the onSave handler, which will take the draft values from the event and pass them to a bulk-safe Apex update method. 2. State your plan. I will start with the Apex controller, creating a cacheable method to fetch the contacts and a non-cacheable update contacts method that accepts a list contact. This update method is critical. It will use a database.update call with all or none equals false to handle partial successes. Then I will build the LWC, define the columns with editable, true, wire up the data, and implement the handle save function to call Apex and then use refresh Apex to update the UI. 3. Code and narrate. As you code, explain the key event and data structures. I'm setting editable, true on these columns. This tells the data table to track changes. When the user clicks save, the table fires the onSave event, and the magic is in event.detail.draftValues. This is an array of objects, where each object has the record's ID and only the fields that were changed. I will pass this array directly to my Apex method. In Apex, I'm using database.update, contacts to update, false. The false parameter is crucial. It tells the system to attempt to save all records, even if some have errors. This allows me to report partial successes back to the user. The component bundle, files we will create. 1. Inline edit data table.html, the UI containing the data table. 2. Inline edit data table.js, logic to fetch data, handle the save event, and refresh. 3. Inline edit data table.js meta.xml, configuration for the account record page. 4. Contact data table controller.cls, Apex with secure fetch and bulk update methods. 5. Contact data table controller test.cls, the test class for our Apex. Here is the user interface HTML file, inline edit data table.html. Disclaimer: always test code in a non-production environment. The data and columns are bound to properties in our JavaScript, similar to a read-only table. These two attributes enable the editing functionality. OnSave wires the datable's save button to our handleSave JavaScript function. Draft values is used to hold the user's unsaved changes. Here is the core logic JavaScript file, inline edit data table.js. Disclaimer: always test code in a non-production environment. The key difference from a read-only table is the editable, true property in the column definitions. This tells the data table to render these cells as editable inputs. The handleSave function is triggered by the onSave event. The event.detail.draftValues property contains an array of the changed rows, which we can pass directly to Apex. On successful save, it is critical to clear the draft values array to remove the yellow highlighting from the table. We then call refresh Apex to fetch the fresh data from the server. The error handling is made more robust by checking for the existence of error.body before trying to access its message property, preventing client-side exceptions. Here is the configuration XML file, inline edit data table.js meta.xml. Disclaimer: always test code in a non-production environment. The target config restricts this component to only be available on account record pages, as it is designed to show related contacts. Here is the Apex controller file, contact data table controller.cls. Disclaimer: always test code in a non-production environment. The update method is marked cacheable equals false as it performs DML. It accepts a list contact, which LWC can deserialize directly from the draft values array. A crucial security check. Since this is a custom Apex DML operation, we must manually verify that the user has FLS permission to edit the fields. This is the key to bulk DML. Using database.update with the all or none parameter set to false tells Salesforce to attempt all updates, even if some records fail validation. This prevents one bad row from failing the entire batch. Here is the Apex test class file, contact data table controller test.cls. Disclaimer: always test code in a non-production environment. To test the update method, we create a list of contact S objects that mimics the draft values the LWC would send. After calling the method, we requery the database to assert that the DML operation was successful and the changes were persisted correctly. Follow-up questions, from junior to senior. Follow-up question 1, your Apex method uses database.update, false. What would happen if a user tried to save 5 rows, but one of them failed a validation rule, and how would you report that to the user? Answer: because I used false for all or none, the 4 valid rows would be saved successfully, and only the 1 invalid row would fail. The database.update call returns an array of database.saveResult objects. I would need to iterate through this array. For each result, I would check result.isSuccess parentheses. If it is false, I would get the error messages using result.getErrors parentheses and build a user-friendly error string. I would then modify my Apex method to return a custom wrapper class containing both a success message for the valid records and a detailed error message for the failed ones, which the LWC could then display. Follow-up question 2. What is the main limitation of using draft values for inline editing, especially with a large number of rows? Answer: the main limitation is that draft values does not support pagination. The Datatable's inline editing feature is designed to work on the data currently loaded and visible on the client. If you have thousands of records and implement client-side or server-side pagination, the draft values from page 1 will be lost when you navigate to page 2. For scenarios requiring edits across a very large, paginated dataset, a different approach is usually better, such as a mass edit page or a flow. Follow-up question 3. Curveball: a new requirement asks for the Datatable's rows to be color-coded based on the contacts level pick list. For example, primary is green. How would you achieve this dynamic row styling? Answer: that's a great question about advanced data table customization. You cannot do this with standard column configurations. The solution is to process the data in JavaScript after it is received from the wire service. I would map over the results and, for each row, add a special CSS class property to it based on the level value. For example, if row.level is equal to primary row underscore row CSS equals SLDS hint parent SLDS theme underscore success /n, you then have to ensure your data is a flattened copy for this to work. It is a powerful way to add conditional, data-driven styling on a row-by-row basis. What the interviewer is really looking for. State management: can you correctly handle the draft values attribute and clear it after a successful save? Bulkification mastery: do you instinctively write a bulk safe Apex method that accepts a list? Do you know about database.update and partial success? Data refresh patterns: do you know that refresh Apex is the correct way to get fresh data into the table after a DML operation? Component lifecycle knowledge: do you understand the lifecycle of the Datatable's edit save refresh process and how the different attributes and events work together? Your turn, the practice challenge. Enhance the save handler to provide more granular feedback. Modify the Apex update contacts method so that it returns a wrapper class containing 2 lists, one for successfully saved contacts and one for contacts that failed. In the LWC, after the save attempt, display a success toast with the count of successful updates, for example, successfully updated 4 contacts, and a separate error toast with the names of the contacts that failed, for example, failed to update, John Doe.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design. Required for your Salesforce jobs interviews like Salesforce LWC Developer jobs, Salesforce Technical Architect jobs, Salesforce Solution Architect jobs, Salesforce Service Cloud Consultant or Specialist jobs, Salesforce Test Engineer jobs, Salesforce DevOps Engineer jobs, Salesforce Marketing Cloud Developer or Consultant or Specialist jobs, Salesforce Admin jobs, Salesforce Developer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based interview questions and answers, real-world problem-solving interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
LWC Coding Challenge 13, the Scalable Data Table with Server-Side Pagination, Advanced Level. Question: what is this challenge and why does it matter? Answer: this challenge addresses one of the most common and critical problems in Salesforce, performance with large data volumes, LDV. A naive query can easily exceed the 50,000 row SOQL limit or result in a slow, unusable page. Server-side pagination is the professional solution. Acing this proves a developer can think beyond simple data retrieval and architect a solution that is performant, scalable, and mindful of governor limits. It tests mastery of state management on both the client, LWC, and server, Apex, a hallmark of an experienced developer. The challenge and interview timebox. The task: an interviewer asks you to build a component to display a list of all account records. Because there could be thousands of accounts, the data must be paginated. The data table should display a set number of records, for example, 10 per page, with previous and next buttons to navigate. The buttons should be disabled when on the first or last page, respectively. Realistic time allocation: core coding task, live 30 to 35 minutes. Full interview discussion, with follow-ups can extend to 50 to 60 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify: great, a server-side pagination challenge for performance. This is a classic LDV pattern. My understanding is I will need an Apex method that accepts a page size and page number. The most important piece will be the Apex return type. It cannot just be a list of records, it needs to be a wrapper class that includes the total record count so the LWC can calculate the total number of pages. 2. State your plan: I will start with the Apex controller. I will create the pagination result wrapper class first, then the main method that uses limit and offset for the data query and a separate count parentheses query for the total. I will also write a test class. On the LWC side, I will manage the state, page number, total pages, etc., and use connected callback to load the initial data. All data fetches, initial and subsequent, will be handled by a single, imperative Apex call function. The button's disabled state will be controlled by reactive getters. 3. Code and narrate: as you code, explain the state management. In my LWC, I'm defining properties for page number and total pages. These are the source of truth for the component's state. My isFirstPage and isLastPage getters are crucial. They derive their value from the state properties, and the LWC framework reactively enables or disables the buttons whenever page number changes. When next is clicked, I'm calling Apex imperatively. This is the correct pattern for user-initiated actions that fetch new data without a full page refresh. The component bundle, files we will create. 1. Paginated data table.html, the UI with the data table and navigation controls. 2. Paginated data table.js, the client-side logic for state management and data fetching. 3. Paginated data table.js meta.xml, configuration to expose the component. 4. Account paginator controller.cls, the Apex controller with the paginating logic. 5. Account paginator controller test.cls, the test class to verify the pagination logic. Here is the user interface HTML file, paginated data table.html. Disclaimer: always test code in a non-production environment. The pagination controls are placed below the data table, using SLDS grid for proper alignment. The button's disabled attribute is bound to a reactive getter, isFirstPage. The LWC framework will automatically disable this button when the getter returns true. This provides essential context to the user, showing their current position within the full data set. These values are updated whenever new data is fetched. Here is the core logic JavaScript file, paginateddatatable.js. Disclaimer: always test code in a non-production environment. We use connected callback to make the initial, imperative call to fetch the first page of data. This is a cleaner pattern than mixing at wire with imperative calls for the same data. These reactive getters derive their Boolean value from the state properties. LWC automatically re-evaluates them when page number or total pages changes. This single, imperative function is used for all data fetches, initial, previous, and next. It sets a loading state, calls apex, and processes the result from the wrapper class. A helper function to process the result from the apex wrapper. It updates the table data, total records, and calculates the total number of pages. Here is the configuration XML file, paginateddatatable.jsmeta.xml. Disclaimer: always test code in a non-production environment. The component is exposed to multiple page types, giving administrators flexibility in where it can be placed. Here is the Apex controller file, account_paginatorcontroller.cls. Disclaimer: always test code in a non-production environment. The inner wrapper class is the key to this pattern. It allows the Apex method to return both the list of records for the current page and the total record count in a single, clean server call. We explicitly note that offset has performance limitations for deep pagination, showing awareness of more advanced, scalable patterns like keyset pagination. The limit and offset clauses in the SOQL query are what perform the actual pagination on the database, ensuring we only retrieve a small, manageable chunk of data. Here is the Apex test class file, account_paginatorcontroller.test.cls. Disclaimer: always test code in a non-production environment. The test for the first page verifies that the wrapper class returns the correct total count and the correct number of records for that page. This test verifies that a full page in the middle of the result set returns the correct number of records. The test for the last page is crucial. It verifies that our offset and limit logic correctly handles the final, partial page of data. Follow-up questions, from junior to senior. Follow-up question 1. Why did you use two separate SOQL queries in Apex instead of just querying all records and paginating them in JavaScript? Answer: querying all records up front would completely defeat the purpose of server-side pagination. If there were 60,000 accounts, a single query would fail by exceeding the 50,000 row SOQL limit. Even with fewer records, sending a massive payload to the LWC would be slow and could hit heap size limits. The entire goal is to only fetch small, manageable chunks of data from the server with each request, which is why the limit and offset approach in Apex is necessary. Follow-up question 2. Senior level: the offset clause is known to have performance issues for very deep pagination, for example, page 1000 of 2000. Why is that, and what is the more scalable alternative? Answer: that's a fantastic question. Offset becomes slow on large tables because the database still has to scan all the rows from the beginning up to the offset point before it can return the result set. For an offset of 100,000, it scans 100,000 rows. The more scalable alternative is keyset pagination, or the seek method. Instead of tracking a page number, you track the ID or assorted field of the last record you saw. The next query would then use a where clause like where name last seen name order by name limit, pagesize. This is much faster because the database can use an index to jump directly to the starting point, regardless of how deep you are in the data set. Follow-up question 3. Curveball: a user is on page 2. Another user archives an account that would have appeared on page 1. What happens when our user clicks previous? How does this affect the user experience? Answer: this highlights the main weakness of offset pagination. It is not stable when the underlying data changes. When the user clicks previous, the offset will be calculated for page 1, and the query will run again on the now modified data. The user will see a list for page 1 that is missing the archived record, and the record that was previously at the top of page 2 will now appear at the bottom of page 1. This can be confusing. Keyset pagination, because it is anchored to a specific record value, is more resilient to these kinds of changes. What the interviewer is really looking for. LDV mindset. Do you immediately recognize that you cannot query all records at once and reach for a pagination pattern? Apex architecture. Can you design a proper wrapper class to return a compound result? Do you know how to use limit and offset? LWC state management. Can you correctly manage client-side state variables like page number and total pages to drive the UI? Knowledge of limitations. Can you discuss the performance characteristics of offset and articulate when a more advanced pattern like keyset pagination would be necessary? Your turn, the practice challenge. Enhance this component by making the page size configurable. Add an @API property for pagesize to the LWC and expose it in the .js meta.xml. Also, add a lightning combo box to the UI to allow the user to change the page size, for example, 5, 10, 25 records per page, on the fly. When the page size changes, the data should refetch, and the pagination should reset to page 1. LWC Coding Challenge 14, the Just Testing Mini Challenge, Cornerstone Level. Question: what is this challenge and why does it matter? Answer: this is a cornerstone challenge that tests a developer's commitment to professional software engineering practices. Alongside scalable data editing, number 12, and scalable data fetching, number 13, automated client-side testing forms the third pillar of enterprise LWC development. Writing code that works is only half the job, ensuring it continues to work is what separates senior developers from the rest. Acing this proves a developer can write resilient, regression-proof components by mocking dependencies, asserting on the DOM, and thinking about a component's behavior in isolation, skills that are absolutely essential for any professional development team. The challenge and interview time box. The task: an interviewer provides you with a simple LWC that fetches and displays a single account's name. The component has 3 states: loading, spinner, data display, and error display. Your task is to write a complete just test file for this component, ensuring you test all 3 conditional rendering paths. You must mock the Apex wire adapter. Realistic time allocation, core coding task, live 20 to 25 minutes. Full interview discussion, with follow-ups can extend to 40 to 45 minutes. How to ace the interview, your thought process. 1. Acknowledge and clarify, excellent, a just testing challenge. This is crucial for code quality. My understanding is I need to write tests for an existing component that uses a wire service. I will focus on the 3 main states: the initial loading state, the success state when data is returned, and the error state when the wire fails. The key will be mocking the Apex wire service to control what data is returned to the component during the test. 2. State your plan. I will structure my test file using the standard arrange, act, assert pattern. I will use a describe block for the component and separated blocks for each of the 3 states. First, I will mock the Apex method called by the wire service. Then, for each test, I will, 1. Arrange, create the component element and add it to the DOM. 2. Act. For the data and error states, I will use the just test adapter for wires to emit mock data or an error. 3. Assert. I will query the component's shadow DOM to verify that the correct elements, spinner, data div, or error div, are rendered, and the incorrect ones are not. 3. Code and narrate. As you code, explain the principles. First, I'm setting up the mock for the Apex call using jest.mock. This is the most important step. It isolates my component from the server. For the data test, I'm using register Apex test wire adapter and its emit function. This simulates the wire service pushing data to my component. After emitting data, I have to wait for the DOM to update. The standard way is to return a promise.result parentheses to push my assertions to the end of the microtask queue, ensuring the component has re-rendered. The component bundle, Files we will test. 1. Account Detail Viewer.html, the UI with conditional rendering. 2. Account Detail Viewer.js, the logic with the wire service call. 3. Account Detail Viewer.js Meta.xml, basic configuration. 4. Account Controller.cls, the simple Apex class being called. 5. __tests _ account detail viewer.test.js, the just test file we will create. Here is the component UI file, account detail viewer.html. Disclaimer: always test code in a non-production environment. The spinner's visibility is controlled by a getter, representing the initial loading state. This template only renders when the wire service successfully returns data. This template now binds to a safe error message getter in the JavaScript, preventing potential template errors if the error structure is unexpected. Here is the component logic file, account detail viewer.js. Disclaimer: always test code in a non-production environment. The component wires a function from an Apex controller to the account property. This property will be populated by the LWC engine with either a data or an error object. This getter provides defensive error handling. It safely checks for the existence of error and error.body using optional chaining, ensuring the component never breaks due to an unexpected error format. Here is the component meta file, account detail viewer.js meta.xml. Disclaimer: always test code in a non-production environment. The component is exposed so it can be placed on a page for manual testing and demonstration. Here is the Apex controller file, account controller.cls. Disclaimer: always test code in a non-production environment. This is the simple, secure Apex method that our LWC will call. It is marked cacheable equals true for use with the wire service. Here is the just test file, __tests _ account detail viewer.test.js. Disclaimer: always test code in a non-production environment. This is a utility from the Salesforce testing library specifically for mocking wire services. We register our imported Apex method with the utility. The returned getAccountAdapter object now gives us control over the wire service for our tests. Our first test covers the initial state. We simply create the component and assert that the spinner is visible immediately, before any data has been emitted. This is the act step. We use the test adapter's emit method to simulate the wire service successfully returning data. This triggers the component's reactive re-render. This is a critical pattern. We must wait for the DOM to update after the wire service emits its data. Returning a resolved promise ensures our assertions run after the re-render is complete. Follow-up questions, from junior to senior. Follow-up question 1. You have tested a wire service. How would your approach change if you needed to test a component that called an Apex method imperatively, for example, on a button click? Answer: the setup is slightly different. Instead of using register Apex test wire adapter, I would mock the imperative Apex method directly. First, my test file would import the method and mock it using jest.mock. Inside the test, I would set the mock's implementation to return a resolved promise with my mock data. Then, I would, 1. Arrange, create the component. 2. Act, find the button in the shadow DOM and dispatch a click event. 3. Assert, after waiting for promises to resolve, I would check the DOM to ensure the UI updated as expected. The key is that I control the mock's return value directly, rather than using an adapter to emit it. Follow-up question 2, this component is simple. How would you test a more complex component that uses both a wire service and Lightning or message service, LMS? Answer: you would mock both dependencies. We have already seen how to mock the Apex wire. For LMS, you would mock the Lightning or message service module. The mock would provide its own implementations of the publish and subscribe functions. For a component that publishes, you could assert that the mock publish function was called with the correct parameters. For a component that subscribes, you could get a reference to the message handler it passes to the mock subscribe function and then call that handler manually in your test to simulate an incoming message. Follow-up question 3, curveball. A team member says, as long as we reach 75% Apex code coverage, our code is good. Why is this a dangerous mindset, and how does just testing help address it? Answer: that's a very dangerous mindset because Apex coverage only tells you which lines of Apex were executed during a test. It tells you nothing about the correctness of the front-end logic or the user experience. You could have 100% Apex coverage, but the LWC might still fail to render the data, handle an error, or disable a button correctly. Jest tests the client-side behavior and the rendered DOM. It answers questions like, when the data loads, does the spinner actually disappear, and if an error occurs, does the user see a friendly message? A combination of both strong Apex tests and strong Jest tests is required for true quality assurance. What the interviewer is really looking for. Testing mindset: do you instinctively think in terms of testable states, loading, success, error? Knowledge of mocking: can you correctly identify and mock external dependencies, particularly Apex calls, which is the most common use case? DOM assertion skills: do you know how to query the shadow DOM to verify the component's output without testing its internal implementation details? Understanding asynchronicity: do you know that you must wait for the DOM to update after an event or data emission, and can you implement the promise.resolve parentheses pattern to do so? Your turn, the practice challenge. Create a new LWC with a button and a placeholder for data. The button, when clicked, will call an imperative Apex method that returns a list of contacts. Write a Jest test for this new component. Your test should, 1. Mock the imperative Apex call. 2. Simulate a user clicking the button. 3. Wait for the asynchronous operation to complete. 4. Assert that the list of contacts is correctly rendered in the DOM. LWC Coding Challenge 15, the Capstone Project, a master detail mini-app, Capstone Project. Question: what is this challenge and why does it matter? Answer: this is the grand finale, the ultimate test of a developer's architectural and system design skills. It moves beyond building isolated components to orchestrating a complete, interactive feature. This challenge requires synthesizing knowledge from across the entire series: search, data display, state management, and component communication, into a single, seamless user experience. Acing this capstone project proves a developer can think at the application level, not just the component level. It demonstrates they can be trusted to own and deliver entire features, making them an invaluable asset to any team. The challenge and interview timebox. The task: an interviewer asks you to build a master detail Account Explorer application. It must have a two-panel layout. The left panel is a searchable list of accounts. When a user searches and clicks on an account in the left panel, the right panel must update to show a list of that account's related contacts. The communication between the two independent panels must be handled by Lightning Message Service, LMS. Realistic time allocation: core coding task, live 35 to 45 minutes, as it involves multiple components. Full interview discussion, with follow-ups, can extend to 60 to 75 minutes. How to ace the interview, Part 1, the strategy and blueprint. 1. Acknowledge and deconstruct: this is a fantastic capstone project. It is a perfect test of system design. My understanding is that I will be building 3 primary LWC components: a parent app container for the layout, an account search publisher, and a contact list subscriber. The key architectural piece will be the LMS channel that decouples the two main panels. 2. Define the data contract first. Before building the components, the most important step is to define the communication contract, the Lightning Message channel. I will define a channel that passes a single account ID field. This ensures both my publisher and subscriber components will be built to the same, clear specification from the start. 3. State your plan and reference past patterns. With the contract defined, I will build the pieces in a logical order: publisher, account search, then subscriber, contact list, and finally the app container to hold them. I will explicitly reuse successful patterns from previous challenges, the debounced, imperative apex search from challenge number 1, and the reactive, wired data table from challenge number 2, but adapted for LMS. This shows I can build on existing, proven solutions. How to ace the interview, Part 2, the execution and communication. 1. Code and narrate the big picture. As you build, explain how the pieces connect. Here in the account search component, the user's click triggers the publish call. This component is now, fire and forget, it does not know or care who is listening. This is the essence of a decoupled architecture. Now, in the contact list, its subscribe method is listening. When it receives the message, it updates its own account ID property, which reactively triggers its wire service. This clean data flow is what makes the application easy to debug and extend. 2. Proactively discuss trade-offs, while coding, show senior-level awareness. I'm choosing LMS here for maximum decoupling. The alternative would be a parent-mediated approach with custom events, which would work but would make the container component more complex and less reusable. For a true app-like experience, LMS is the superior choice because these panels are true siblings. 3. Manage your time and scope. Given the time box, I'm focusing on the core functionality first. I will ensure the search publish subscribe render loop is working perfectly. Features like error handling on the search input or adding a create button to the contact list would be excellent next steps if time permits, but a solid, working foundation is the top priority. The component bundle, a full application. 1. Account selected channel.message channel meta.xml, the central communication hub. 2. Account search component, publisher HTML, JS, meta. 3. Contact list component, subscriber HTML, JS, meta. 4. Account contact app container component, orchestrator HTML, JS, meta. 5. Account search controller.cls and account search controller test.cls, Apex for searching accounts. 6. Contact controller.cls and contact controller test.cls, Apex for fetching related contacts. The communication hub, account selected channel.message channel meta.xml. Disclaimer, always test code in a non-production environment. Defining the message fields creates a clear, data contract for our application. Any component that uses this channel knows to expect an account ID field in the payload. The publisher UI, account search.html. Disclaimer, always test code in a non-production environment. This is the trigger for the entire application's workflow. The onClick event calls the handleSelect method, which will publish the selected account's ID to the message channel. The publisher logic, account search.js. Disclaimer, always test code in a non-production environment. Instead of a custom event, this component uses publish from Lightning or message service. It sends the account ID over the application scope channel, fully decoupling it from any subscribers. The subscriber UI, contactlist.html. Disclaimer, always test code in a non-production environment. This template provides contextual feedback. The message will change based on whether an account is selected or if the selected account simply has no contacts, which is a polished UX. The subscriber logic, contactlist.js. Disclaimer, always test code in a non-production environment. The component subscribes to the LMS channel as soon as it is on the page. The message handler is a simple arrow function that updates the selected account ID property. This is the reactive core of the component. The $ makes selected account ID reactive. Whenever the LMS handler updates this property, the wire service automatically refires and fetches the contacts for the newly selected account. The app container UI, account contact app container.html. Disclaimer, always test code in a non-production environment. The container component's only job is orchestration and layout. It uses a simple SLDS grid to place the two independent child components side by side, creating the application structure. The apex for account search, account search controller.cls. Disclaimer: always test code in a non-production environment. The search method is marked cacheable equals false because it is called imperatively based on user input, and we always want the freshest results. The apex test for account search controller test.cls. Disclaimer: always test code in a non-production environment. This test verifies that the search method correctly finds and returns records based on the provided search term. The apex for contact list, contact controller.cls. Disclaimer: always test code in a non-production environment. The method to get related contacts is marked cacheable equals true as it is a perfect use case for the LWC wire service. The apex test for contact list, contact controller test.cls. Disclaimer: always test code in a non-production environment. This test verifies that the controller correctly filters and returns only the contacts related to the specified account ID. Follow-up questions, from junior to senior. Follow-up question 1, you chose LMS for communication. Why was that the correct choice here over a standard custom event or using a public API property? Answer: API properties are for parent-to-child communication, and these two panels are siblings, so that would not work. A custom event is for child-to-parent communication. We could have the search component fire an event, have the container listen, and then have the container pass the ID down to the contact list via an API property. However, this creates coupling. The container now has to be a middleman. LMS is superior here because it completely decouples the publisher from the subscriber. The search panel can broadcast its message without caring if anyone is listening, and the contact list can listen without caring where the message came from. This allows either component to be replaced or used elsewhere in the application without breaking the other. Follow-up question 2, how would you scale this application to include an Edit button on the contact list that opens a modal to edit the contact's details? Answer: this is a great question about extending the architecture. I would apply the patterns from our previous challenges. First, I would add row actions to the data table in contact list, like in challenge number 12. When the edit action is clicked, contact list would open a reusable modal component, like challenge number 3. This modal would contain a form, perhaps the Lightning Record Edit form, like challenge number 4, pre-populated with the selected contact's ID. When the form is successfully saved, it would fire a success event, which the contact list would handle by calling refresh apex on its wire to show the updated data. Follow-up question 3, curveball: a user selects an account and sees the contacts. They refresh the browser page. The selection is lost. How could you architect a solution to preserve the state across a page refresh? Answer: this is an excellent question about advanced state management. The current solution state is purely client-side and ephemeral. To preserve it, I would need to store the selected account ID in the URL. I would use the Lightning or Navigation Services current page reference wire adapter to read the URL parameters on load. When a user selects an account, instead of just publishing to LMS, I would also use the navigation mixin to update the URL with the new account ID as a query parameter, for example, c__account ID equals. This has two benefits: the state is preserved on refresh, and the URL is now bookmarkable and shareable. What the interviewer is really looking for. System design: can you deconstruct a feature request into a logical set of independent, communicating components? Architectural choice: do you know why and when to use a specific communication pattern like LMS over another? Synthesis of skills: can you combine patterns learned in previous, simpler challenges, search, data display, state management, into a single, cohesive application? Capstone composure: can you manage complexity, narrate trade-offs, and still deliver a working solution under interview time pressure? Your turn, the final challenge. Complete the final piece of the application. Add a Create New Contact button to the contact list component. This button should be disabled until an account has been selected. When clicked, it should open a reusable modal that contains a Lightning Record Edit form to create a new contact, automatically associating it with the currently selected account. Upon successful creation, the modal should close, and the contact list data table must automatically refresh to show the new record. Here is a skeleton of the modal component to get you started. Practice challenge skeleton, create contact modal.html. Disclaimer, always test code in a non-production environment. This skeleton leverages a reusable modal, like the one from challenge number 3, demonstrating how a component library can be used to build features quickly. The form uses Lightning Data Service, which handles the creation and security checks automatically. It is wired to call the handleSuccess method upon a successful save. The account ID is pre-populated from a public property and hidden from the user. This is the key to ensuring the new contact is automatically related to the correct account. Practice challenge skeleton, create contact modal.js. Disclaimer, always test code in a non-production environment. The component exposes public properties to allow a parent component, like contact list, to control its visibility and pass in the required account ID. Upon successful save, this method performs 3 actions. It shows a confirmation toast, fires a contact created event to notify the parent that it needs to refresh its data, and then fires a close event to hide itself.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your Salesforce jobs interviews like Salesforce LWC Developer jobs, Salesforce Technical Architect jobs, Salesforce Solution Architect jobs, Salesforce Service Cloud Consultant or Specialist jobs, Salesforce Test Engineer jobs, Salesforce DevOps Engineer jobs, Salesforce Marketing Cloud Developer or Consultant or Specialist jobs, Salesforce Admin jobs, Salesforce Developer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based interview questions and answers, real-world problem-solving interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more that will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.